All right, guys, welcome to the class. Couple of things. Let me just do the introduction in terms of what are the different things that I'm going to be covering in the class, the format of the class, how I'm going to be covering it, and then we'll get started. First of all, welcome to the class. It is about an overview of software-defined networking, specifically looking at a software-defined access and then software-defined wide area networking. I am recording the class. You should have sound now. Can you guys hear me? Yeah, so good. I think it should be on your side, guys, because on my side, I have good speed. That's what I'm saying. I'm going to be recording the class on my side. It is too many people to go down the list and give you the ability to record. All right. And so what I'm going to do is I am going to be recording the class on my own rather than going down the list and clicking on each one of you guys. There's a lot of people over here. So I'm going to record the class and I will provide the video for you guys after the class is done. It takes about an hour or 2 hours to render. I'll send you an email with a link to download the video and watch it. It is a class, if you've never heard about software-defined networking or are not aware of it, you've heard about it, but you're not aware of how it works. This will give you a very good insight of what software-defined networking is all about, specifically SDA access and SD-WAN. Not only that, you will be able to communicate or talk to people and understand when they talk about the terminology that goes along with these type of technologies, how or what they're talking about. All right. In terms of the questions, because there are just too many, it is very hard for me to keep on answering as I'm going along. So what I'll do is I will start doing I'll do the lecture. I'm not going to take answers at that point. I will share them as well, Barak. Ahmed, on your side, guys, voice is okay. Voice is fine. Check on your side. So I'm going to talk about the technology, and at a certain point, I'll ask you guys if you have any questions regarding that. Let's try to keep the questions to what I've talked about, all right? Rather than when is the class going to be, what is the technology, what are labs, and those type of things. Let's focus on the things that I have talked about at that time. It makes it easier for the class to flow through. Maybe the question that you have, I might be answering in the next section. So, okay? So just keep those questions focused on the stuff that I have talked about or the technology that I've talked about at that point, because otherwise it goes in tangents. This class is specifically for software-defined networking from Cisco, but at the same time, the overall field, the technology is still the same. So it doesn't change too much from one vendor to the other. But in terms of the products, yes, I am going to be focusing on Cisco products specifically, but the concept's the same. All right, everybody good with this? You guys ready to go with it? So what I'm going to do is I'm going to minimize the chat right now. So I'm not looking at the chats because that does distract me as I go through it. I'll go through it, and the point that I'm ready to have you ask the questions, I'll let you know. So if you're putting on the chat, it's unnecessary because I'm not looking at it. All right, otherwise, it's not effective in terms of the way the meeting goes on a big audience. We have close to 250 people over here. All right, so let's get started with that. What is this all about? Now, the first thing that I want to talk about over here is if you haven't gotten into it yet, it is the time to get into it. This is the future of networking. What you would have 5 or 10 people, 20 people do in terms of the work. Now you have the ability to you can centralize a single centralized pane or window where you can configure a lot of the devices. And that software-defined networks and software-defined access. Ahmed, it is on your side. I cannot help you. You need to check your system. Everyone else is listening. First of all, what does that mean? What is the focus of software-defined? Focus is centralized. I would say management. Then going in and configuring multiple sets of devices. You have hundreds of devices in your environment. Rather than configuring each is focused on is the ability that you have a centralized controller where you configure all the devices, the components of your network, and push the configuration onto all the devices. So you don't have people going in configuring individual. What are the two things? What are the differences between SD access and SD-WAN? When I talked about this controller-based setup, this applies to campus network. It applies to your wide area network. In terms of the different technologies that basically fulfill these requirements for these different type of networks, you have ACI that Cisco has that fulfills the requirement over here. You have SD access, which is there responsible for the campus, and you have SD-WAN, which is responsible for allowing you the same controller-based networking for the wider network side of things. Today, we're not focusing on ACI on the data center part. Our focus today is going to be on SD access, which is for the campus, and SD-WAN, which is for your wide area network. All right. Again, what is the focus again? It is about controller-based networking. In a controller-based networking environment, what they've done is they have broken down the control plane to a different technology, data plane to a different technology, and in some cases, different devices. And the third one is which I call the management plane into a different technology. Everybody okay with this? So you have basically broken down what you would normally do by going onto the same device, logging in, telnetting in, SSHing into the device, and then configuring it. What you're doing now is you're doing all of those things sitting in one place. One person's doing the job of multiple set of people. So the thing about this that you need to be aware of is in the future going forward, you will have a lot more networks that will be coming up. But at the same time, the amount of work a single networking engineer will be doing is going to be a lot less because the same person has the ability now to do a lot more work sitting in one place. Not only that, in today's environment where we are locked in our houses all around the world, this, as we go through it, you'll understand you have the ability to control the entire network sitting in one place from home remotely. You have the ability to do that because once you have access to that controller, the controller is the one that will actually push the configurations down to all the different devices. All right, so it actually really affects the way it is happening right now. Okay, so again, the questions, guys, some of you guys might have joined in late. Please keep your questions and comments for right now. Don't put them in over here. I will answer the questions at a certain time because if I keep on answering the questions, this is a huge class. It will never finish. So just keep the questions at this point. I will tell you if you have any questions about the topic that I've covered, I'll be more than happy to answer those for you guys. So now that we have broken down the configuration down into the control plane, data plane, and management plane, what we'll do is we'll focus on this in terms of how does it work with the campus environment and your wide area network. The campus is your SDA. This is SD-WAN. Now, these two things are not actual devices. These two are technologies, but in order to implement these technologies, whether it's SDA or it is SD-WAN, you are going to be requiring certain devices that the company needs to acquire or purchase to be able to implement that. The switches are going to be different, the routers are going to be different, the edge devices are going to be different, the software is going to be different, and we'll take a look at that. So with that in mind, let's get started with the first one, which is the campus network, which is managed using SDN by using this mechanism, this technology called software-defined access. The first thing that you need to understand about software-defined access is software-defined access is meant for your campus network, your enterprise network. When you go into an enterprise, whether it's a college, whether it's a company, you want to manage the network infrastructure over there, the endpoints that are connecting into your network. You have a bunch of different edge switches, the access switches that you guys have. A network administrator in today's day and age will need to go in, telnet in, or SSH into these devices and be able to configure it. Now, to ease that load, you do have tools that Cisco provides, like Cisco Prime, that does allow you the ability to control this element, to be able to control multiple switches from a centralized location, but it's just for the purpose of management. It's a network management software. It doesn't give you the ability to control your control plane, does not give you the ability to control your data plane. It is specifically meant for the management plane part of it. That's the Cisco Prime, right? So again, the ability to control or configure your devices, all the different devices, predominantly over here, we're looking at switches, predominantly. There are certain routing functionalities over here as well, but most of the time when we're talking about SD access, it is predominantly from the functionality of switching, your network. Now, one of the biggest problems or drawbacks that you have in a campus environment is STP. STP is a mechanism that allows you the ability to provide a loop-free environment in a switched or layer 2 network. All right. So to make sure there are no loops in this environment, you run STP, which generally speaking is run automatically, which is good. It avoids loops. But the problem with STP is it also leads to inefficient forwarding, where STP might, if you don't tune it properly, it might block a link that might be an optimal link for traffic going from point A to point B. So STP invariably ends up blocking links to avoid loops. So the first thing that SD access does, besides doing the controller part of it, now we go into the data, the control part of it, is avoid or get rid of STP. So SDA, actually in a switch environment with SDA, there is no STP. So that's the first difference. So it gets rid of STP. Instead, what it does, it allows these links that you have over here to now become routed links. So there is no layer 2 that is running over here between the switches. Instead, you run routing over here. You basically assign every loop, switch a loopback address. And once you assign the loopback address to each of those switches, you run some type of routing protocol. What type of routing protocol can you run? Any of those normal ones that you have You can run OSPF, you can run, if you're running a Cisco type environment, EIGRP or ISIS, any of the IGPs that you want to run. The main purpose of the routing protocol over here is to provide reachability for switch 1, switch 2, switch 3, and switch 4. So once these 4 switches are routable with this, the default, if you do, if Cisco does it automatically, it will run ISIS as a protocol. Yes, ISIS for me is a great protocol. It is something that is easy to run. It's good for the future as well. It's got a lot of advantages. So ISIS would be recommended, and it is the default if you let Cisco run it. So basically you run that. This protocol over here is the purpose, the only purpose is to provide reachability for what? For the switches. All right. So it is not being used for end user connectivity. So it's not being used or has nothing to do with the end users. Its main focus is to provide reachability so that the control plane of the different switches has multiple different ways of getting from point A to point B. The good part about a routing protocol is because of its own built-in loop avoidance mechanisms, equal cost multipathing capabilities, you do have multiple redundant paths that are active at the same time. So if you have an equal cost between 2 switches, it is going to make both the links active, unlike STP, where there would not be dual links. It will block the links and you would only have 1 link available. So the first thing that you need to understand is with STP, your worries about making sure your network is a loop-free environment, which is done through STP, is no longer there. It is done by SDA by using a routing protocol. And this routing protocol, by the way, it has a terminology. So if you ever hear about the terminology called the underlay routing, they are referring to this type of stuff. To basically, underlay is basically the infrastructure that allows the other devices to communicate to each other. Not necessarily, Farhan, underlay is not necessarily physical. I'm running a routing protocol over here. So underlay over here has nothing to do with physical. So it is more to do with a service that provides a service for another type of service. So underlay allows you the ability to run the main purpose of what we're doing over here, which is something else. So underlay provides the connectivity. Over here, the underlay routing protocol that we have is either going to be OSPF, ISIS, EIGRP. All right. So the purpose over here is to provide control plane connectivity between the different devices. So how does it work? The way it works is, first of all, what happens is when you connect up a SDA network, you have 2 elements to it. Let me show you this diagram over here, where you have the centralized controller that is responsible for managing the entire infrastructure. So that is called DNAC, DNA Center, basically. It's an appliance. It's actually a UCS C-Series server with a specific application installed on it called the DNAC, or the DNA Center. This is the heart of your SDA network. This is where all the administrators log in, browse to it, and this is your single management plane. So everything that you do is from this device known as the DNAC. It's a UCS C-Series server. It sits on a network which allows you the ability to connect up to the other devices. Guys, questions later on, please. So once I have the DNAC set up, the next thing that I need to do is provide reachability using a normal switch. This, I'll tell you what the fusion part of it is later on, but it could be any switch that allows the DNAC access to your fabric. This is where your SDA resides. This is where the actual SDA equipment is at. The red switches over here are your specific SDA compliant switches. So these switches cannot be your normal switches that you've been running in the environment. There are specific switches that you need to purchase with the SDA capability. So these are SDA capable switches. The DNAC using routing over the enterprise network will have access to these edge devices known as the border switches. These are also known as seed switches for the discovery of your fabric. This part over here is known as the campus fabric. Now, what happens in this type of environment is using either LAN automation, which is a feature of DNAC, you have the ability to use the seed switch over here to discover the entire network over here automatically. Or if you do that, if you use the LAN automation feature, it is not only used to discover the switches, it is also used to set your underlay. And if you allow network automation to discover your first switch, from the first switch, it discovers the other switches, and the other switches then in turn will discover the edge switches. These are basically what we refer to as the access switches in today's day and age. In your SDA terminology, these are called fabric edges or edge switches. The edge switches are also discovered by the seed switch one at a time. It will discover this switch over here. He will in turn discover all the other switches. A process which is very similar to in ACI, the spines and leaves being discovered. So once the discovery takes place through this automation of LAN, through this process of LAN automation, it uses, as I said, guys, these questions, hang in there, write them down and put them in later on. I will answer the questions at the time that I can. So they use SNMP, they use LLDP, CDP, they use a bunch of different tools to actually discover and configure these devices. Now, once this discovery is done, it runs a routing protocol automatically. And if you let it do it over here, the routing protocol that it runs is ISIS. So if you let Cisco do the LAN automation to set your fabric up, in that case, your underlying routing protocol that is set up on these devices is your ISIS protocol. As I said earlier on, you have the ability to do it based on Cisco LAN automation. In that case, it's ISIS. Now, if you don't want LAN automation to pick ISIS as a protocol, maybe you don't have engineers that are comfortable with ISIS, which happens a lot. So what you have the ability to do is to discover the network. You also have the ability to do it manually. In the manual mechanism, it's your responsibility to make sure that your underlying routing protocol allows you the ability to have all these devices configured with a routing protocol. If you're doing it on your own, you have the ability to use any protocol. If you want, you're more comfortable with OSPF as your underlying routing protocol, you're comfortable with EIGRP as your routing protocol, you do have the capability of doing that. The main thing that you need to understand that you're doing with these protocols is you have to create a loopback over here on each one of those switches that make up the SDA fabric. And once you create that loopback, you run that in the routing protocol so that each edge is aware of each other via this underlying switch infrastructure. Now, does the underlying infrastructure that is connecting your borders, which are towards your DNAC, and edge, which is towards your endpoint, do they have to be SDA compliant? These guys over here, they don't. If you want, you can run them as your normal layer 3 devices. This could actually be a router. It could be a layer 3 switch, a normal layer 3 switch, a switch that does not necessarily have to be SDA compliant. So if you don't want to spend extra money to get a SDA compliant switch in the underlay, you have the ability to get your normal existing L3 switches and provide reachability between the different borders and between the different edges. You might say, why do you want to do that if you have it in the middle like that? It gives you the ability to have more redundant paths. Maybe your topology is in a certain way that you do want to expand and give yourself the ability to expand. This becomes your underlay, and this could technically be a non-SDA switch. What you need to have as SDA switches, you have basically 3 or 4, depends on how you want to look at it, types of devices for SDA. The first one is the one that connects up towards your endpoint. So it is a special switch that will connect up towards the endpoint. This is known as the fabric edge. This is similar to your access layer switch. So the fabric edge is the switch that connects up towards your endpoint. This could be a 9200, a 9300, a 3800, 4500, a whole list of different type of SDA enabled switches. Now, the thing that you need to understand is not just the model of the switch. It also requires that you have the appropriate licensing on the switch so that the switch, although the hardware is there, it's also software-wise compatible with SDA. So it's a combination of hardware and software licensing that allows the switch to act as an SDA-enabled switch. And this switch is known as the fabric edge. The purpose of the fabric edge is to connect up to the endpoints over here. What's an endpoint over here? This could be your laptop. This could be your printer. This is your normal access layer switch. This could be an iPad over using a Wi-Fi type of network where you have an access point. Even the access points connect up over here. So using access points, you have your iPads, your handhelds, all of those type of things can connect up. So that's your edge switch over here. The edge switch connects up to the other edge switches using the underlay protocol. All right. Now, the other type of switch that you guys have over here is this border switch. Border switch is the switch between the SDA fabric that connects the SDA fabric to the rest of the world. Now, what is rest of the world? The rest of the world could be your WAN. So over here, this could be your private WAN over here. Or the rest of the world could be the internet. So if you want your endpoint to go to the internet, it is going to go from this edge to this border through this underlay, and the border then is responsible for sending this device into the internet. If this guy over here wants to do a connection to another site that belongs to you, it's on the private WAN, he'll go to the edge will send that traffic to the border over here, and the border will send the traffic to the external site. So the border is the one that connects the fabric on one side to the routed network, the other part of the network on the other side. So that's the other device. Now, there are two types of borders that you have. There's a border known as the known border. The known border is basically your private WAN device. Maybe this is the device that learns all the routes from your MPLS, VPN, your service provider, connecting your different sites to each other. This is where your WAN edge for SD-WAN can also reside. That's the known border. Known basically is known routes. So if you want to go and connect up to the private WAN, you're going to use the known border device to go out. But let's say you want to go to the internet. Generally on the internet, you don't have all the routes from the internet. So you send the border over here is basically the device that connects you to unknown routes. Unknown routes are not specific routes. Basically the 000 route. So the default route. This is also sometimes referred to as the default border. So you have a known border and an unknown border over here that would allow you the ability to connect these devices to either the private WAN or the internet. So all those other type of devices like load balancers, all that will be outside. They will not be inside because these are all layer 3 devices. So they would be advertising the routes to the border, and the border will be sending the routes inside the fabric. So far, guys, later on questions, please, huh? So you have the private WAN, which is connecting to the MPLS network. This would be your known border. The reason it's called the known border is because the routes are known, that they're specific routes. This is the unknown border. This is the one that connects up to the internet. So again, this is not, the border route itself is not the internet router. It's going to be connecting to the internet router to go out. Now, the way it works, and you see another device over here called the control plane device. Now, this plays a big part over here. This is the device that is responsible for mapping the endpoints to each other. This is the way communication works in SDA environments. And once I do the overview over here, I'll open it up to the questions. So for right now, you guys pay attention. This is very important, and this is a completely new way of doing networking. So whatever you have learned about in the past is going to change with what I'm going to talk about right now. We have been told that if you want a device to communicate to another device, it's not on the same subnet. You need to go through the router to do it. The whole thing goes out for a toss based on what I'm going to talk about right now over here. The way it works is this. In a normal environment, when I have an endpoint, let's say it's a normal switch, and I have a PC over here, and switch, whether it's a DHCP request, whether it's a login request, it comes up, it might have some updates that are going across, it will send a packet into the switch. As soon as a packet comes into a normal switch, and I'm not even talking about, at this point, I'm not even talking about doing anything specific. It's just any type of packet coming in on a normal switch, not even an SDA switch. In a normal switch, what would happen over here is that when the packet comes in, the switch uses a mechanism called MAC learning. In the MAC learning process, what happens is the switch will learn that this particular MAC address, MAC1, is connected to port, let's say 5. And this is not something special. This happens on every single normal switch that you have. Now, this is what happens in a normal switch over here. What does SDA add to it? What the SDA adds to it is another element. It also finds out information about not only the MAC address of the device, let's say it's MAC1, it also learns about the IP of that device. How does it learn it? It actually looks into the layer 3 of the packet and finds out what the IP address is. And because a normal packet, when it gets sent across from a PC, it does not put the mask on that IP. So what the switch, the edge switch over here will do, it assigns everyone a /32 address. So it's a unique identifier for this endpoint. All right? These two things, along with the port number that it came in off, let's say it's port number 5, is put into your local table over here. Let's call this table the local station table. And ARP table does not have a port number associated with it. ARP just has a MAC and IP. So MAC, IP, and the port number on this particular switch. Once I learn it, what this switch will do is it will send that information across. Yeah, I'm just trying to make it easy, like the 20,000 feet overview of it. It'll send that information across to this device using the protocol called LISP, in which it's going to tell him, hey, listen, you know what? I know about this IP address 10.1.1.5, and if you have somebody looking for it, please send it to me. And when he says, please send it to me, do you guys remember that I told you that the underlay protocol over here provided reachability for those loopbacks? For every device, I had a loopback created as part of my initial setup. So it would learn all those loopback addresses and have reachability, and it provides that information to him saying, hey, listen, if you want to get to 10.1.1.1, please send it to me. My IP address is 192.168.1.11. For example, this is the switches, the fabric edges loopback, which is routed by using ISIS or OSPF or EIGRP, whatever your protocol is. Similarly, when this guy over here comes up, let's say he is MAC2, his IP address is 10.125/32 again, because I don't care about his mask, and he's connected to port 7 on this local switch. As soon as he gets that information, he's also going to make an announcement, a registration announcement, again to the control device and saying, hey, listen, I have a device that has registered to me, which is 10.1.2.5, and my IP address is, let's say, 172.16.1.15, and this is again my FE loopback. So now this control device that you have over here using the LISP protocol is aware of every single host that exists that are connected behind which particular fabric edge that you have. Okay, now the other concept that is new over here is when you are configuring this, all this configuration, by the way, the IP addresses that are being assigned to your host, the DHCP pools, the IP addresses assigned, the loopbacks assigned to the edges, the loopbacks assigned to the borders of the control, all of that control, all that configuration, do you need to actually go to the edges and the borders and the control to do that? The answer is no. All the configuration, including the IP addresses that you need to configure, are all done on the DNAC. And the DNAC using its own protocols, SNMP, there's you can do SSH, there's a whole bunch of different management protocols that they use that actually are configuring these devices. So you're not actually going in on the edges and configuring it, you're doing all the configurations from a centralized location called the DNAC, where you're pushing this configuration. All my host, the pool for my old host addresses is going to be from this particular range. If I want to reach if I want to run my protocol over here as OSPF or ISIS, I would configure that over here. So all that type of stuff is done centrally over here, okay? So once I learn this on my resolver, which is this guy, by the way, if you heard this in your terminology, this guy over here is known as the R-lock. This is the locator for your router or the device that will be allowing you to connect up to it. Each of the fabric edges or the FE devices will have a associated R-lock for it. That's basically the loopback address to reach that particular device. And this is the end ID, the endpoint identifier, which is the IP address of the device itself. Good. So everyone now, every device that gets registered over here is on this particular device. Now, the other thing that I need to do over here is when I'm assigning IP addresses to these particular devices, I also specify their default gateway. And this is something that you need to be aware of, which is completely different. SD Access uses this component or this way of working, which is called the Anycast gateway. So let's say the default gateway for 10.1.1.5 is 10.1.1.254/24. That's the default gateway. On the DNAC, I specify that my subnet that I have is 10.1.1.0, and the default gateway for that subnet is 10.1.1.254. The DNAC automatically configures that SVI with the same IP address on all the different edge devices. So all the edge devices, unlike in your normal environment where you cannot have two devices having the same IP, here every edge device that you have will share the same IP address. So if I have 5 edges, all 5 edges will have a SVI created with the same IP address assigned. There's no conflict. The reason for that is what they want to do is whenever an endpoint sends a resolution that it needs to communicate to another device, the resolution will be done by the local F edge, the fabric edge. It does not need to go beyond the first fabric edge. So he becomes your router for all your endpoints over here. He becomes a router for all your endpoints over here. Let's say I have 2 subnets. Every device over here, every fabric edge will have two SVIs created, and all the SVIs will have the same IP addresses. So let's pick one VLAN over here, VLAN 1001 as an example. And that one has a default gateway of 10.1.1.254. This VLAN identifier and the IP address will be assigned to each one of those edges. Similarly, when you have VLAN 102, you'll have 10.1.2.254 assigned to each one of those devices. So by doing that, when this device does an R for the default gateway, the local edge will answer. When he does a R for the local device, his local fabric edge will answer. It's not going to go beyond that. So it makes it very efficient for routing to take place if you have routing that needs to take place between different VLANs. So this is a concept that is not there in your existing non-software-defined access or software-defined networking that is introduced not only over here, it's also in ACI. If you work with ACI, it's the same type of concept over there. So let's do an example over here. Let's take a look at a couple communications that will make you understand that. The first thing, I want you guys to answer this for me. Do you guys understand that every device over here has a loopback? And that loopback is reachable throughout the fabric by using an underlay protocol. Everybody understand that, right? Give me the yeses on that. Yeah? So that is done automatically, that every device that you have over here has a loopback, and it is advertised automatically using an underlay protocol that could be anything, OSPF, PIGRP, ISIS, including the control. The two switches in the middle are just any switches. If you want to extend or scale your network, these are known as underlay switches that basically provide reachability between the borders, edges, and the control device. They could be SDA switches. They don't need to be SDA switches. This could be any layer 3 switch in the middle to expand or scale your network without having to do too much with the cost. These switches, the SDA-enabled switches, are more expensive, so you can get a normal switch to do that. Why do we need these switches in between? You don't need it. Need is too strong of a word. It gives you the ability to expand your network. So if you have a lot of different edge switches and you want to be giving yourself expandability, scalability, you can put the two switches over here. If you don't want them, you can actually connect the borders directly to the edges, but then your limitations are in terms of scalability. Got it? So it's not required, but it's there. I'll get into that. I wanted one answer, one question from you guys. Do you guys understand that their reachability is there? Yeah? So everything is done based on this underlay protocol that provides reachability between the edge devices. So everyone's aware of that. Now what I want to do is I have two different VLANs or two different subnets that I've created because I have a lot of devices. I have 10.1.1.0 with the default gateway as 10.1.1.254, and I have 10.1.2.0 with the default gateway of 10.1.2.254 as my default gateway. I'll create that on the DNAC and I'll tell them that these are the two subnets that my endpoints are going to be connected to. As soon as I do that, what the DNAC does, it configures two SVIs on all your switches. The SVIs will be for 10.1.1.254, and it'll have another SVI as if you have an interface VLAN 10 and 20 with another IP address of 10.1.2.254. So you'll have two SVIs over here. Good so far? Not only on this one, I will also have it over here. I'll also have it over here, also have it over here, also have it over here. That would be done through your DHCP server. In the DHCP server, you would push the IP address to your endpoints. So the endpoint gets its IP address and IP configuration not from the edge switches, it gets it from the DHCP server. So when the port comes up, it sends a request, it'll send it to the DHCP server, it gets an IP address, subnet mask, default gateway, all those configurations, DNS server from the DHCP server. And in that configuration on the DHCP server, it will tell it that this is your DHCP server, this is the particular DHCP server. So now that I have that, I have the SPIs on all the different devices. Now, let's take a look at a normal communication. I want to talk about communication between two devices on the same switch. Actually, I'll put 3 devices over here. And let's take a look at the communication between 3 devices on the same switch. I have one endpoint over here. I have multiple endpoints over here, right? So I have, let's say, 10.1.1.5. I put 1 as that, /24, 10.1.1.6, /24, and 10.1.2.10, let's say, /24. Let me write it clearly. These are my 3 devices over here. Now, this device, as soon as it comes up, it will send a registry, it'll send some packet over here, and the MAC learning will happen along with the IP address. So now the edge switches over here will know about, in that table, MAC 1 is 10.1.1.5/24. It's connected to port 5, let's say. MAC 2 is 10.1.1.6/24. It's connected to port 6. And I have MAC for MAC 3. This is MAC 2. This is MAC 3. 10.1.2.10/24. And this is, let's say, on port 7. Now, if I want to communicate between 10.1.1.5 and 10.1.1.6, what is the process? Let's say over here, I send a ping, 10.1.1.5 pinging 10.1.1.6. The PC over here goes through a process known as the ANDing process to figure out if this device is on my subnet or is it on a different subnet. By looking at the 2 devices and looking at its own subnet mask, it knows 10.1.1.5 and 10.1.1.6 are on the same subnet. So if that's the case, I need to find the layer 2 address, the MAC address of it. It's going to send an ARP request saying who is 10.1.1.6. When that ARP request comes into the edge device already knows that the MAC address for 10.1.1.6 is MAC 2. So immediately the fabric edge switch can tell the sending device, hey, listen, when you send this packet out, you're going to send it to 10.1.1.6. His MAC address is MAC 2. Based on that information, he would have done a packet. He would have created a packet that looks like this. The MAC address is MAC 1. Destination is MAC 2. And the IPs are 10.1.1.5 going to 10.1.1.6. And how did the edge know the MAC address of the first device? Because it does the MAC learning. Now it's taking a more active part in this whole process where it learns the MAC address and answers back on behalf of that. So this is a communication that took place from here to here. Once the edge device receives it, it sees the MAC 2, it knows MAC 2 is on this port, forwards the packet over here. You guys understand this? This is normal. This is nothing new. This is exactly the same way that a normal switch would work. You guys okay with this? Communication between 10.1.1.5 to 10.1.1.6. Now, the beauty of it is this. When 10.1.1.5 wants to communicate to 10.1.2.10, what is the procedure on that? So when I try to communicate from 10.1.1.5 to 10.1.1.5 to 10.1.2.10, so my ping is now going from 10.1.1.5 to 10.1.2.10. Again, the ANDing process will take place, and in this ANDing process, the PC over here figures out that my source and the destination are on different networks. If that's the case, what does the PC do at that point in terms of ARP? Does it ARP for 10.1.2.10 or does it ARP for something else? It doesn't send to the gateway. It's finds the ARP it finds a MAC address for the gateway, right? Now, what is the gateway for 10.1.1.0 network that the DHCP server told the endpoint? It's 10.1.1.254. And where is 10.1.1.254? Which of these switches is 10.1.1.254? The local edge. So if I have 10.1 and 10.1 or 10.1 over here, let's say this is 10.1.1.9, communicating to this device. Oops, sorry. I have 10.1.1.7 over here, /24, communicating to 10.1.2.5 over here, versus this 10.1.1.5 communicating to 10.1.2.10. Who's the routing device for them if they're on the same network or on the same switch? It's a local edge. Do you understand what I'm trying to tell you? That's the beauty of what? Anycast gateway. So if two devices, even though they're on two different subnets, want to communicate to each other, they will communicate to each other on the same switch. The traffic does not need to leave the switch. It will be handled by the local switch. In today's day and age, I'm going to send that traffic to either my distribution or the core to get routed to come back. Isn't that true? Because my SVI is not on the local device. It's going to be somewhere in the distribution layer or the core layer, depending on what model that you use. So that's the first thing that I had to make sure you guys understand is the concept of the Anycast gateway. So the communication between two hosts on the local switch is handled by the local fabric edge. It does not need to leave the fabric edge to go out if the source and the destination devices happen to be on the same switch. Now, what happens if I want to communicate between this guy and this guy, which are on two different switches? Same concept. The border I haven't talked about. We'll get to the border later on, right? Let's focus on within the fabric right now. So 10.1.1.5 and 10.1.2.5, they want to communicate to each other. ARP request for the default gateway, he gets it. But now he does not know where 10.1.2.5 is because this guy over here will only know about what? This switch, let's call it fabric edge 1, knows about what devices by default? What devices does it know about it at this point? And not even the controller. The controller does not play any part in that. Controller is just for the management part of it. The local device by default only knows about the local devices, the connected devices. Because the local connected devices, it uses the same learning process that Mac learning does. It only knows about the local devices. Good? No, I'm talking about this device only knows about local edges, right? So if I want to communicate from 10.1.1.5 to 10.1.2.5, it does not know that. It does not send that information to DNAC for forwarding. What it does is, remember what I told you, as soon as somebody registers onto the edge device, what does it do? It sends that information to what? The C device. This is known as a control plane device, not the controller. Controller is over here. Controller is for management. That's what this switch is, using the protocol called Lisp. It sends it to this control device. In this device, it will have the endpoint identifier. Okay. In the endpoint identifier, it would say, if you want to reach 10.1.1.5/32, the RLOC or your edge device is your 172.16.1.11. That would be the loopback for FE1. Similarly, it would also know that 10.1.2.5 is located behind 172.16.1. Let's say 15. So when it does not find a packet that is going from 10.1.1.5 to 10.1.2.5, when it does not know that it is over here, it will send that packet to the not the packet, but a request to the control device, asking him, how do I reach this guy? What is the answer from the C device? The control device over here, using a list, what does it tell it? Hey, listen, you know what? 1.1.2.5 or 10.1.2.5 is located behind 172.16.1.15. You get my point? So he tells him that. He will tell him that, listen, if you want to reach 10.1.2.5, you need to go to 172.16.1.15. That's where the endpoint resides at. So what is the protocol that I used over here for this communication to make this work from here to here? What was the protocol that was used over here? Was Lisp, right? Once I learn that information, I will keep that information in a cache so the next time I don't need to use it. I now know that if I want to reach this over here, I need to go to this particular IP. At that point, you would have this device set up a tunnel with directly from its loopback, which is 172.16.1.11 to the loopback of 172.16.1.15. All right, it'll send it directly between the two devices using a protocol called VXLAN. This is a tunneling protocol. In this tunneling protocol, just to give you a 20,000 feet overview, basically what it's going to have is it's going to have the outside header, which looks like 172.16.1.11 to 172.16.1.15. And in there will be that 10.1.10.1. address. Encapsulated, this packet is VXLAN. This is whatever your inner header is. Got it? So now the packet will be routed using this information, which is over here. Through the underlay, it will tell him, hey, listen, if you want to reach 172.16.1.15, that's connected over here. He sends it to him. He sends it over here. Whether it's the same subnet or a different subnet, it doesn't matter, because now I'm doing routing based on /32. You cannot have two /32s on the same network that need to communicate to each other. Every device needs to have a unique address assigned to it. Good so far, guys? So that has nothing to do with the controller. The controller is doing what for you? It is not part of your data forwarding. It's not part of your control plane. What is this doing for you? The actual configuration where I set these IP addresses up, where I configure the edges to communicate to each other, that is configured from where? From DNAC, and the DNAC will push that configuration to whom? The DNAC's job is not to be in the flow of data or the control plane. His job is to go to the border, via the border, send the traffic to whom? Or not the traffic, sorry. The configuration of what I just told you about, like the SVIs, and configure them on these devices. Its job is not to be involved in the actual tables. Yes, you can see the tables over here, but that's using management. So you're basically logging in and taking a look at the table, the control. You can see the table of the endpoints. You can do all of that through the DNAC. Same concept when the packet. So a good question over here in terms of what I was actually doing. The question is, let's say this endpoint is 10.1.1.5/24, and this is 10.1.1.7/24. He sends an ARP. For whom? 10.1.1.7. Why? Because they're on the same subnet. I don't have that information because I don't know about that address. I don't know about 10.1.1.7. So what do I do in that point? I'm going to send that request to whom? Him. Do you know where 10.1.1.7 is? And through Lisp, it's going to tell me, hey, listen, yeah, I know where 10.1.1 is. It's behind FE, let's say 5. And the same procedure now works. And then it creates the VXLAN tunnel, create the tunnel between the two edges, and that's where they communicate to each other. Now, that's next. First, I wanted to establish that the connectivity is automatically done. So one of the first things that we need to worry about is making sure our subnets are correctly done, our devices are communicating to each other. Technically, the biggest problem that we have today is that we need to worry about VLAN, subnets, and all that type of stuff, right? The first thing that we can do over here, I can assign all my endpoints on the same subnet, 10.0.0.0/8, and have the DHCP server give out IP addresses to those devices. Everybody okay with that? So I don't need to worry about the connectivity part of it. Why? The connectivity is taken care of. The good point is that means every device now can communicate to every device. Well, it has the ability to connect, right? The actual ability to access those devices, that is controlled using another mechanism, and that's what I'm going to do next. But I wanted to make sure you understand one thing over here is that I don't need to worry about the management of those VLAN subnets to control traffic from one device to the other. That is gone. I don't need to worry about that. I can if I want to, but there's no need for it. So the main thing that I wanted to establish over here is now at this point, accessibility, all the endpoints very easily can talk to everyone. So now how do I control that? How do I specify which device communicates to what device? It can be done at two different levels. You can do what is known as macro segmentation. Which is basically creating VRFs. VRFs in SDA terminology is known as a virtual segment or VN, virtual network. Oops, sorry. This is a VN, a virtual network. So what I can do is when the devices come up, based on the configuration of the SDA, when a user logs in, based on the login authentication, based on MAC address or a username password, I can put the device, the port, this particular port, into a particular VN. So I can have different VNs created for different type of MAC addresses, or you can do it based on username password authentication. Good so far? So the first thing that we did over here was we got rid of the communication headaches that we have in terms of management, right? So now that we have that, they're segregated. They can only communicate from green to green and pink to pink. They will not be able to communicate between the green to the pink at this point. Okay? You guys good with this? Let's say I did want some traffic to go across from green to pink. That's where I need to send the traffic. I need to do what is known as inter VRF communications. That is not handled by the fabric. So what happens in that case, the packet will be sent to your border. Border will send it to the external router over here. The external router gets the packet from one VRF, and you configure the fusion router over here, whose job is to allow the inter-VRF communications, to allow the packet to go back out, but into the other VRF. Whether it's on the same edge or it's on a different edge, it really doesn't matter. It's one VN to another VN. It does not tunnel from an end to an sender to a receiver. It's from the switch to the switch. It's a VXLAN tunnel. So the purpose of the fusion router over here now is to do what? Inter VRF communications. And what is this inter VRF communications called? It is basically called macro segmentation. So you basically are putting the devices into different VRFs. And what is the criteria for putting these devices into different VRFs? How do I put the device into a particular VR? What's the communication mechanism over there? The mechanism over there is when this port comes out, based on MAB, use a different color, based on either MAB, MAC-based authentication based on the MAC address, or if you're doing username password authentication, you can do it based on the user. So the user could log in over here, or the user could log in over here, or the user could log in over here. So the user could log in on any one of those devices. Wherever he logs in, he will get the same VRF assigned because that VRF is either linked to your user or to the MAC address based on whichever one that you're doing. So that's where ICE comes in. ICE over here will have a direct, when I go to the DNAC, I will configure the switch with the address of the ICE device so that it can go and do the authentication over here to ICE, and ICE will tell it what VRF it belongs to. That particular port address belongs to at that particular point. Any inter-VN communication will go to the Fusion boarder to get routed. It's basically allowing you to communicate between two VRFs. All right. Now that's one aspect of it. That is basically VRF based. There's another way to do it, which is more commonly done. You have the ability to do, I think, Tarun, it's on your side. So over here, the better way of doing it is by doing what are known as security group tags. A mechanism of ICE again. When the user logs in or the MAC address logs in, the user assigns that device or that particular port a tag. Let's say the tag is 5,000. It's just a number. And this device that is also over here in the network, he logs in or that gets connected. He has a tag of 5001. Although they might belong to the same VN, as soon as they log in, they get assigned a tag based on their login authentication. Now, what you do once you tag them, you create what are known as SDA-ACLs, security group tag ACLs, which controls which device can communicate to what device. You get my point? So this is even within the VN, based on what user is logging in. You're assigning every user a tag, and it's not like every user gets its own tag. Every set of users gets its own tag. So for example, when people from the sales department log in, I can say all those users that are coming in from the sales department get a tag of 5,000. All the sales servers, based on their MAC addresses, are residing in with a tag of 5001. And I write an SDA-ACL allowing the 5,000 tag to communicate to the 5001 tag. Based on the MAC address, based on the username password, you're giving that access. And everything, all of this is done through DNAC, even the configuration of ICE. You have the ability to do it in ICE, or you can launch into DNAC, and DNAC connects you into ICE with an API. So ICE plays a big part in terms of communication between the different devices over here. Now, the intra-VN communication is handled by the SGTs. This type of stuff is known as micro segmentation. So we have a macro segmentation and we have a micro segmentation. You don't need, it's good to have ICE expertise. It is not required to have ICE expertise because you're doing very specific things with ICE. It helps if you know ICE. ACLs are deployed directly to the endpoints, yes. All right, so let's take a look at what are the different things that we have talked about, and let's see if these terms mean anything to you now. And we'll review it. So device discovery, we talked about it. What are the two different ways of doing it? And after this, I'll give you the chance to ask the questions. So this device discovery using DNAC, using either what? PNP, plug and play, or manual. If I use plug and play, what, or LAN automation is the name for it. If I use LAN automation plug and play, what underlay protocol are you going to use? ISIS. Otherwise, you can use any underlay. And what's the purpose of for the underlay? Why did I use the underlay? What was the purpose of underlay? The reachability of the switches, correct? So I'm eliminating STP completely. I'm doing everything based on your routing. Good. The next thing is device management. Where do I do all the device managements from? Everything, all I talked about in terms of configuration wise, all the configuration is done from a centralized location called the DNAC. Got it? So if somebody talks to you about DNAC versus SDA, do you guys understand the difference? SDA is the overall architecture, whereas DNAC is the controller that makes it happen. Good so far? So this one is also done. Not only that, if you want to actually do more than this, you also have the ability to do things like software upgrades. Device maintenance can also be done over here. So if you want to upgrade your switches, you can do it from your device management over here as well. So you actually don't need to go to your switches one by one and do it. So remember what I told you, you have one person that's doing the job of multiple people over here. So is it going to cut down on the number of people that is required to do a big job? Yeah, absolutely. You better be the one to know it, right? Rather than being the one that's getting eliminated, getting redundant. Do you need to, you still need Prime? This Prime just does the device administration. If you have SDA, then the Prime part, I don't need to worry about. This does a lot more than Prime. Without the downtime depends on the switches. It still needs to do a reload, but I don't need to go and have a person go on to each and every switch and do it. I can do it centrally. You for the DNAC, you can do it as a cluster. So you can have a cluster to do it. So you don't need to have one, you can have multiples to do that. But again, when you log in, you log into the cluster IP to do that. Fabric communication. Do you guys understand this? Basically, yes. That is correct, Imran. It's, remember what I told you, it's SDN. At the end of the day, it is software-defined network. So you have other vendors doing it, very similar. Again, because the communication between the different devices is done based on what? ECMP, you don't need to worry about what? Ether channels. You can still set up multiple links between two switches, but they're layer 3 switches now. Good so far? Now, you guys understand this part, right? The control device. The purpose of the control device is to do what? The list, the map server. It does a lot more than that. Remember what I told you? It does max security. It does everything that ICE does in terms of endpoint management, because all that is handled by ICE. No, we'll focus on one site over here. It's like an RR, yeah. Now, what are the other devices in the fabric besides that? We looked at that as well. We talked about the border devices. We talked about the fabric edges. Do you remember this? The border devices. What is the purpose of the border device? It's the communicator between the fabric and the outside world. Border, yes and no, in terms of that is like a leaf in ACI, because it also, the leaf, you can also call this a leaf because it's connecting to the end device. Where do you think it resides? If the border is the one that connects you to the outside world, where should it reside? It should reside either before or after this private WAN. In reality, some of the people, what they do is they implement the private WAN or the known border, the devices that they connect up to, as your firewalls. Because firewalls nowadays have routing capabilities. Now, one last thing I want to talk about that over here. Now, remember this over here? Let's say this device wants to communicate to some device over here on the private WAN. Again, outside. All those devices are outside that. So that would be on your, that doesn't change. That would be behind your firewall, inside the firewall. That network is outside the fabric. So let's say I had some device that this wants to communicate to. Remember what I told you, this is the known border, right? The known border would advertise all the routes it has over here to him. And he would also have the RLOC. So those addresses, the addresses that are not within the fabric, would be announced to the control plane by the border devices. So when this device wants to communicate to that, it will send that ARP to the switch. Switch will send that request to the control plane. The control plane will say, hey, listen, the IP address, which is not inside your fabric, is known via the border. Router locator, it's the loopback address for each one of those switches. That's exactly what it is. It's a little bit more than just a simple access layer switch. It's also the routing device now. You can have a couple of control borders over there. Absolutely can and should have that because of what? The control plane brain, Marwan, rather than the complete brain, because DNAC also plays a big part. Controller is not your single point of failure, Tarun, because as I said, you see one controller over here. It is really a cluster. Control plane device, CP. Is there any difference between the border and the FEs? The actual device is the same. Now, the other thing that you can know, these devices, the B, the B, the C, all of these are SDA-enabled devices. Now, one more thing that I want you to think about is that if I want, not something that you would do, but for cost cutting, these three devices are functionalities. They would all or could be on the same physical device. Okay? Connectivity to the internet, as I said, the known device is this guy, the known border. He would advertise all the specific routes. This is the unknown border. This would advertise the default route. And he would get the 000 route from him, and he would send it to him, and he will forward it across to the internet. Again, you have redundancy. If you don't have, that's something that comes with anything. If you have a single core switch, what happens? Those things happen over here as well. So you have, if you want to have redundancy, you will need to add more devices over here. You get my point? So those things are always there. I just want you guys to understand the functionality of the device. You can definitely do that. You can do you can actually do the known, the unknown border, and the C on the same device. These are functionalities. So you can have multiple routers as SHA. Absolutely can. Or you can do it as a single device. Expensive. One-time cost about 70,000 list dollars. The purpose of Fusion was to communicate between two different VRFs. So VN, inter-VN communication. You're talking about 10 gig speeds over here. The L2 versus L3 is good when you're talking about going to the service provider. This is the fabric that you're talking about. Can we use OTV here, underlay in SDN? No, you don't use OTV over here. They have their own mechanisms to do a stretch between two different data centers if you want to. Yeah, but for this, because everything is done through the control plane for the DNAC, you need to do it based on SDA switches. It's not just pure list that you're running over here. No, I won't, Godwin. Everything will be on the single campus. BGP can be used as the underlay, yes. Does a VXLAN tunnel create? Yeah, there's a VXLAN tunnel created between the border and the edges. Not required anymore. Everything of that is done through SDA-ACLs. Anything that does inter-VLAN routing. Fabric is within your company, George. Over here. But you can stretch the fabric if you want to another device. There are certain response time requirements that you need to have. SGT stands for security group tags. It's just a number to basically identify the endpoint. VXLAN basically is a tunneling technology that is a generic technology that allows you to tunnel layer 3 traffic within layer 3 traffic. I'm using that to communicate between the endpoints to carry the endpoint traffic within the outer header, and they're using VXLAN to do that. This device in VXLAN technology would be your VTEP. You can actually call this a VTEP if you want. So you can call it a fabric edge, but if you're looking at it from the perspective of VXLAN, it is VTEP. Who will push the SDTs to the edge devices? When the users log in, they get authenticated through ICE. So ICE is the one that will push that SGT and the SGT-ACL down to the endpoints. Yes, you can configure the fabric between two DCs if you want to. The security between the endpoints is done through SDA-ACLs, or if you want, you can do the macro segmentation based on VRF. It's almost mandatory in SDA. If you don't want to do micro segmentation, you can do without it, but generally speaking, whoever is implementing SD access is doing micro segmentation, which is through SGT-ACL. The WAN could be anything, that just requires connectivity. It is done automatically when you configure it through DNAC. DNAC will do that for you. VRF communication depends on how you're doing it. It can be done through ICE. If you're doing, for example, if you're doing a username password authentication through ICE, it's going to push it. No, you can have the same DNAC manage same DNAC cluster manage multiple sites. Fusion router, what was it? You guys slowly. Can we use another protocol? No, you don't have a choice in these protocols. You cannot use anything except for VXLAN to communicate between the V edges. You cannot use anything other than list to do that. No, I still have SD-WAN to cover. We'll take a break and we'll come back to that. No, it doesn't. It's clear text. VXLAN is clear text. How do we connect the fabric edge at one device to the, again, how did I connect this over here? through the, how did I connect up this guy over here? It connected through the router. It doesn't, from once I leave the fabric, it doesn't, I don't really know where the DNAC is, whether it's local or it's somewhere else. So I will do normal routing to get to the DNAC. You're within your data center, George. So you're not leaving your data center. So within that transport, there's no encryption right over here. How do you connect SD device? The edges? Is Fusion router needed if you use ICE? Remember what the Fusion router was used for? It was to connect between two different VRFs. So if you're not doing inter-VRF communication, you don't need the Fusion router. When the user logs in, he gets authenticated based on ICE, and ICE will tell it what VLAN it belongs to, and based on that, it'll get the proper IP address. How do we connect the SD device to the cloud? Which SD device are you talking about? The edges? You need to understand, this is on your campus. This is to connect to your end device, right? After this, we're going to go to SD-WAN. How will the physical connectivity FE and BE through the fabric, meaning they're connected to the underlay physically using Ethernet, right? No, it has to be outside. The Fusion router has to be outside the fabric. For doing inter-VRF communication, because these devices over here will be communicating to two different subnets. Those devices will be announced by the border router to the CLOC. So because they're communicating over here, it'll go through there. It is recommended to have a fabric per site. Can you do it? Can you spread it across? Yes, you can, but it's recommended that you do it per site, per campus, basically. It basically, the Fusion router is a BGP router that does inter-VRF communication. Absolutely. Through SGTs. You can't communicate to each other unless you have the proper SGTs. MPBGP, that is correct. When a device logs in and he connects up, he gets assigned to an SGT, it can only communicate to devices with the same SGT by default. So if it wants to communicate to any other device that's not in its, is using the same SGT, you need to write an ACL for them to communicate. So by default, they will not be able to communicate to anyone. So you need to whitelist it and specify where it can, who it can communicate to. Fusion router can be a router or a firewall, correct. It's a layer 3 device, basically. So it can be a switch, a L3 switch. Do you have to, or is there? See, Ishtiaq over here, if you take a look at it, I have done this, as I said earlier on, just for scalability. If I wanted to, I could have the B and the C's and the E's all connected to each other directly. Understand? So the only purpose I kept the two devices over here gives me more scalability. Very, very similar. Very similar. It's going away. Not really required as much. The VLANs is, even in your ACI, if you take a look at it, VLAN is not, VXLAN is pretty much taking over. If it's a small campus with one edge, I would not do DNAC for that. The WLC. The WLC is a device that allows you to communicate to the access points the WLC can be connected over here. So what happens is when a access point registers, it uses CAPAP to communicate, and it will communicate to the WLC. The WLC has to be a SDA aware WLC for it to work properly. The access point has to be SDA aware. If that happens, what happens is this device over here, the WLC will tell the access point, go ahead and create a VXLAN tunnel between the access point and the endpoint. So there'll be a VXLAN tunnel over here between the access point and WLC rather than using CAPAP. The CAPAP is gone. RLOC is just the IP address of the different devices that are inside your fabric. Reachability, routing reachability, the locator for those devices inside the fabric. Not in this class. If your DHCP in the endpoint, how does it know which VN network it belongs to? When it goes over here, the border router will send the request on this based on a particular IP subnet. So it's at that point, it's leaving your normal, your SDA fabric. So the request will come in from a particular IP address. You connect the servers over here to any of those devices. And when you connect the servers on the edges, you basically, based on their MAC addresses, you associate SGTs with them. How will the SDA solution work? If my LAN environment is extended to remote locations as well via L2 MPLS or P2P links, it absolutely works. You use VXLAN, you do EVPN to extend your fabric using the L2 VNI across. You use BGP EVPN to do that. Controller from connection from edge to internet via the controller? No. I think I explained that multiple times. The unknown border over here announces the default gateway to the control border. So the edge finds out, hey, listen, I want to go to the internet. I don't know the route. He says, any unknown route, send it to this guy. So he'll set up a VXLAN tunnel to the unknown border, which sends it to the internet. Is IP to MAC address necessary? Yes, absolutely. That's how the edge knows which port the MAC address is assigned to locally. That's within the fabric over here, Avinash. Again, same question. Any layer 3 device is outside over here. This is your campus fabric over here, guys. It's not VLAN anymore. It's all done based on VXLAN. Firewall is outside your campus fabric. Firewall is to connect your outside network into your campus. Is that right? So the fabric, where would the firewall be? It would be either in front of or behind your private WAN or the internet device. Can C or B be directly connected? Absolutely can. They can be on the same device if you want. All right, guys, this will go on forever if you keep on doing it. Let's move on to the next one. But before we do that, let's take a look at the things that I needed to finish over here. Make sure you understand these things now. So device discovery we talked about. Device management we talked about. What a control device is, that's the Lisp server. The communication is based on VXLAN. Border devices, known and unknown. This is for the internet. And this is for your private WAN. All through DHCP, when they come up, the port comes up, you do MAB on those. That MAC address is associated with a particular subnet. Everything with DNAC is done through the graphical interface. You do nothing from the command line. Macro segmentation, you guys are okay with. Micro segmentation, you guys are okay with, right? The stuff that we talked about over here, yes, it is specifically for what? This is specifically for Cisco devices. And you also know the purpose of the Fusion router, right? What is a Fusion router used with? This guy. So that is SD access for you guys. This is a 20,000 feet overview. In terms of the specifics, I have a complete outline in terms of the different labs that we'll be doing over here. Let me just pull that up. So there's about 31 labs that I've designed around this. Right from the get-go, how do you integrate it? How do you bring it up? How do you do the different pools that you need to create? How do you define your AAA server? There's about 31 labs in the full course. Prerequisites is probably going to be basic switching and basic routing, CCNP level routing. The class is recorded. I'll send you a link. Sure, in the email after the class, I'll send you an email with it. Yes, this is part of the CCI EI track. Not only that, but it's also, I'm also doing an upgrade class. So if you want to join the upgrade class, you can do that as well. So there's about 31 labs for that. And these are labs that when you join the class, you get access to the physical equipment. I have my own lab for the for SDA. So this is all done on physical. This is something that you cannot virtualize. For SDA, it's 550. You get about 20 hours to do the labs, and you should be able to finish these labs in 20 hours. No, I put an extra 5. Starting Sunday. Yes, you can. Oh, this is just SDA. Let's take a break right now. We will take a 15-minute break. We'll come back, and then we'll take a look at the SDA part, which I haven't covered yet. So that's coming up. This one about 3 weeks, 5 hours a day. So let's take a break. We'll come back, and we'll take a look at the SD-WAN. We're going to use this as our, I'll talk about the class itself towards the end. So 11:15 to 11:30, 15 minutes based on this. Yes, I do the CCI security class as well. It is part of the enterprise infrastructure CCIE. Let's take a break. We'll do it after the break. 15 minutes, guys. We'll come back and we'll do SD-WAN. Okay, you guys. Ready to get started again? All right. Same deal. Now I'm going to take a look at SD-WAN. Again, I'll give you an overview, and then once I'm done, I'll go through the questions. SD access, you might have some people deploy it, some people might not because of the expense factor to it, existing campus environment, requirements or limitations or challenges. SD-WAN, in my opinion, is a technology that is going to be there for a while coming up. It is a fabulous technology. Let me give you an overview of what SD-WAN offers you. Let's say I have an existing environment right now. I want to connect different sites of mine to each other. I have one site over here, let's say the headquarters site. A second, let me get this straightened out. So I have my headquarters site over here, which has an edge device, let's say a router. You have another 3 sites over here. Actually, let me put a cloud in the middle. And this is my internet that I'm using to connect up, or I can use maybe my MPLS network to connect up. So I can use this link over here, going through my private WAN to connect my sites to each other. With MPLS, I get end-to-end quality of service, end-to-end guarantee of traffic reaching the destination with a certain level of service level agreement. I can also connect the same sites as a backup through the internet. So I have 2 different transports that are available to me to connect my different sites to each other. Now, all my traffic at this point, generally, because of my full routing that is happening through MPLS, will go over here. Where as my internet traffic that I go to the internet for goes over here, but the backup links that I'm using for the different sites to connect up, I'm not really utilizing that. Not only that, again, remember the software-defined part of it. Right now, without doing any software-defined elements to it, all the different devices would need to be configured individually. I want to set up DMVPN. I want to set up GetVPN. I want to do any type of configuration. I need to do that individually on these devices. So that's the first thing that SD-WAN brings to the table. It gives you the ability of using a controller-based setup that allows you the ability to manage. The management plane can be done from a central device called a controller that will allow you the ability to configure these edge devices to connect up. That's the first element to it. The other element of it is in terms of your policies, the way the routing takes place. You have the ability using policies in SD-WAN to specify what traffic will be sent over MPLS, what traffic will be used to that can use the internet to go across. So for example, if I don't have any time-sensitive traffic, I do have the ability to utilize this internet link to connect in over here, leaving my MPLS link for more traffic for my time-sensitive applications like voice, video, those type of things. Right now, the way it's done, if you want to do it, it's a complete task to be able to go in onto each and every router and tell them using maybe PBR or using routing to specify, okay, only the specific routes that are pertaining to voice and video come through MPLS. The rest of them go through maybe a DMVPN tunnel to go across. All right. The same things can be easily accomplished on a controller-based system by using SD-WAN. You have the ability by looking at deep packet inspection to pick the transport that a particular site uses to go from one site to the other. So you can specify if I have web traffic, or maybe you might have traffic like a specific custom application. You might have an Oracle database over here. You can do routing. We're using a mechanism in SD-WAN called app-aware routing, where the router decides by looking at a deep packet inspection whether the traffic should go through MPLS or it should go through the internet. If it's voice traffic, go here. If it's web traffic, go through the internet. So you have the ability to use all of that using a centralized model. Same type of concept, centralized configuration of the devices. There's a specific underlying protocol that you use. You have specific type of devices that will be used or utilized for this. What are the different components of SD-WAN? The controllers, they have broken the controllers down. Do you guys remember the controller that I had in SDA? We just talked about it. We have the single controller called the DNAC. And in terms of policy, it used the ICE device, integration with ICE. With SD-WAN, they have specific devices that are used for the three different planes that I talked about. There's management plane. There is a control plane. And then there's a data plane. Over here, same type of thing. Yeah, the only difference is these type of things in terms of controller, there's three separate type of controllers for each one. All the management, like your DNAC configuration, is done through vManage. The control, which is the routing portion, is done through a device known as vSmart. And the actual edge devices that communicate for end user data is called a vEdge. There is another device called vBond. And I'll explain that to you guys what that controller does as well. So the first thing I want you guys to understand, just like you had the DNAC and ICE over here, you have a similar type of thing called a vManage, a vBond, a vSmart, and a vEdge. vEdge is like your fabric edge in your SDA fabric. All right? So that's the first thing that I want you guys to understand, that you have a controller-based system where the DNAC, what you had in SDA, is broken down over here into three different components. Now, the purpose of each one. The vManage is just for configurations. All the configurations are done by vManage for the entire setup. So even if you have 50 sites, everything is done through vManage. Whether it is to configure the policies of what device to communicate to what device, how do they work, everything done through vManage. Then you have another device called vSmart. This is your control plane device. Its responsibility is to run the specific proprietary protocol that is used in SD-WAN for propagation of routes. What is a routing protocol that you generally use in your wide area networks? You have OSPF, BGP, ISIs, those type of protocols. In SD-WAN, it uses its own protocol for the control plane, which is called the Overlay Management Protocol, OMP. So the route propagation is specifically done by using this protocol called OMP. Let me show you a diagram, and then we'll discuss that over here. So my controllers, if you guys take a look at it, my vManager, vSmart, and vBond is located over here. This could be in the cloud. This could be in your data center. This could be in your headquarters. It's connected via the MPLS cloud and the internet cloud to these three edges that I have. I have London, Dubai, and I think this is LA. Let me just scroll up a bit. Yeah, this is LA. All right. So I have these three locations over here. Now, the first thing that I need to make sure that I have routing. So my underlay over here is your MPLS cloud or maybe static routes through the internet that basically allow the vManager, the vSmart, and the vBond to have connectivity to the vEdge devices. The vEdge device over here is your WAN edge device. Specific device. Now, the first thing that needs to happen is that they need to have reachability, IP reachability between that. That is done through the underlay, whatever the underlay is. Now, once that's done, in terms of your actual routing that needs to be done, these are your internal networks that need to be routed through the WAN. That is exchanged between the vEdges, not with each other. They all exchange that information with your vSmart. So all the routing is set up between the vEdges and the vSmart. He gets all the routes. He acts like a route reflector and reflects the routes to all the other vEdges. So all the routes that I learned from London, he'll send it to Dubai, and Los Angeles, and vice versa. So all the different edges know about all the different routes through the vSmart. Although it learns it, although it sets up its your routing connections between the vSmart and the vEdge, the actual data traffic is done in a full mesh manner. So the vEdge over here wanting to go from this network to this network has the option of using either this path or using this path. All right, so the data traffic does not go through the controllers. It's just the management, that is the configuration part of it, and the routing, which is the specific routing protocol that is used over here, which is OMP. Good, so you guys are okay with that? So you understand that? Give me the go ahead. Any questions about what I just talked about? I don't want generic questions right now, just the things that I talked about. Everybody okay with this? The purpose of this? Hang in there, make that judgment after I'm done with the entire thing. You don't need to, but it gives you the ability to use one as a forwarding and the other one as a backup. So if I had one site that is just connected to the internet, that's also okay. So I could have a site over here connecting. Again, you need to have redundancy over there. I'm just showing you one vSmart. You can set up multiple vSmarts. The routers will not talk control plane with each other. Absolutely correct. Yes, it is. And you'll see that in a second. Traditional routing does not offer SLA-based routing, application-aware routing, all those type of things. Even better, Javed, absolutely. You can set them in the cloud in different locations. Now, so far, okay, this is good. And so far, I've talked about this guy, I've talked about this guy, and I've talked about this guy. So this one, again, is your management plane. This is your control plane. And this is your data plane. Now, what is this guy over here? This one, although they call it the orchestration plane, I call it the authentication plane. When these devices come up, when the edges come up, these devices initially, they do not go to the vSmart or the vManage. The first job that they have is to go and talk to the vBond. all of them come in and start their communication by going to VBON. Once they establish a connection to VBON, the VBON authenticates these devices to see if they're valid edge devices in my network. This is done by using certificates, where each device over here, each edge device is assigned an identity certificate, and the identity certificate is validated by a root certificate at the VBON. So once these are authenticated, VBON then tells these devices, hey, listen, you're authenticated properly. The IP address of your vManage is X, and the IP address of your vSmart is Y. Understood? So the purpose of VBON is done. Its job was to authenticate the device and direct them towards the vManage and vSmart. I'll answer those questions. Let me finish this and you'll get the answer. So the VBON, I would not compare it completely with ICE, because ICE does a lot more than just authenticate and direct them towards vManage and vSmart. Over here, its job is just to authenticate and point them towards the other devices. Got it? Everybody okay with this? So you understand that. These are different VMs, Ryan. These are not physical devices. Okay? Each one is a separate VM. So yes, they can all reside on the same box, but these are three separate VMs. So you still, even if it's a single ESXi server, you would need to install three different VMs. But these are three separate VMs, so it's not a single VM that does more than one device. So now that we've established the different devices over here that make up the whole SD-WAN architecture, the next thing that I want to take a look at over here. So overview of this SD-WAN, orchestration using zero-touch provisioning. Is vEdge a physical device? Well, vEdge, it's a good question. Let me answer that because it deals with the device role itself. The vEdge over here, I just told you this is what? These are all VMs. These are not physical devices. vEdges come in both versions. They come in as VMs. They come in as physical devices. And the difference over there, the main difference over here is the processing power. The physical devices that you can have a Viptela device called the vEdge, which is a physical device. There are different series for them. It can come in as a CSR, which is, again, it's not a physical device. Actually, that would go under virtual again. So this is CSR. No. Yeah, CSR is a cloud service router. It's a VM. So this would also be a vEdge VM. But then there's also the ISRs and ASRs that you get as physical devices. So you have a physical vEdge, which is the Viptela device, and the Cisco ISR and ASR. These are all physical devices that you have. So you have a VM version of it, and then you have a physical version of it as well. So vEdge, when we talk about vEdge, it is a physical device from Viptela, which is Cisco now. The better term that they call them, rather than calling them vEdges or cEdges, the term that they want you to use is a WAN edge, which would include vEdge, cEdge, your Viptela, this is both physical or logical, C-Edge, and the ISRs, the ASRs, all of them. This is basically it. PE and CE devices, this is considered to be your CE device. The PE is a provider edge device, which is over here. I'll explain that. Don't worry about those type of things at this point. All right? Good, you guys understand that. So this is your edge device. So that took care of, where is this? The role device, the understanding the device roles. Now, orchestration with zero-touch provisioning. Now, I'll do a couple of things over here in terms of the configuration. I'll answer that when the time's right. I need to get this infrastructure up and running. So how do I do it? Now, if you get a physical device, which is either your V-Edge physical device, your ISR, or ASR. No underlay is irrelevant. Basically anything, you can run anything over there. You can run internet, MPLS, you can run cellular, it doesn't matter as long as I get connectivity from one edge to the other edge. As long as I have IP connectivity, I don't really care what the underlay is. So V-Edge, ISR, ASR. There is a process known as zero-touch provisioning. What does that do? These devices, when they come from Cisco, they're pre-configured with a couple of things. Number one, they have a pre-installed certificate, which is their own identifying certificate called the ID cert, which is pre-installed on all the physical devices. Let's assume these 4 devices over here are physical V-Edges. They are also configured with an address as the address of your vBond. This address is ztp.viptela.com. It's pre-configured. All right. So as soon as you plug this device in, it gets an IP address assigned, maybe from the internet, from the ISP. As soon as it gets an IP address assigned to it on the interface, it will go and try to connect up to this particular address for the vBond. Do you guys remember what I told you? The first device that the V-Edges have to connect up into. What does it have to be? Where does the V-Edge have to connect up to? The vBond. And I just gave it the address. I gave it the address as well, I didn't give it. It was part of the initial config of that device, the physical device. ztp.viptela.com. It will try to make a communication to that based on the DHCP address that has been given to it. Generally not through the MPLS. This is something that would happen over the internet, because with MPLS, you'll probably have to run some type of routing. So generally done through a public cloud. So it gets an IP address. It uses ztp.viptela.com, makes a connection to the vBond. The vBond that you have, what the company would have done is, in order to do all these devices, all these different V-Edges, the company for SD-WAN requires itself to be registered at Cisco on the Cisco, what is known as the PNP portal, in which you specify the name of your organization. Let's say it's KBITS. And in there, I specify basically the licenses for all my V-Edges. So these are physical edges. So I would have registered my devices over here on the PNP portal. And my organization would be on the Cisco cloud. It will basically tell it what is the vBond for this particular device. So when this guy would connect up into ztp.viptela.com, it would identify itself based on its what? Its certificate. Cisco looks at that certificate, says, oh, this certificate belongs to KBITS because I have registered it over here. And the kbits VBOND is located at that particular location, redirects the V edge to Viptela. So that means companies cannot use gray area routers. Absolutely correct, Imran. They're configuring or controlling this based on these licenses that are done on the PNP portal. It's based on a subscription model. That is wrong. That is wrong, Hikmat. I'll explain that when you go through the whole lecture, you'll understand MPLS still plays a part over here. MPLS is a transport used by SD-WAN as one of the transports it uses. So it's not in a competition with MPLS, to be honest with you. That's a misconception people have. So let's understand that. So based on that, the VBOND, where I have specified the certificates, will validate the V edges, and it'll tell them where the vSmart and vManage is. So if you want, you actually did not need to configure anything on the V edge. The V edge will go and register with the VBOND. The VBOND will tell it where the vSmart and vManage is. They make a connection over here. As soon as the connection is made by the V edge to the vManager, on the vManager, you can configure what are known as templates. And these devices that come in, they get registered over here based on the templates, which is templates of configurations. It will push the configuration onto what? These devices, and these devices will come up in as part of the configuration. It will also tell it what routing protocol it should run over here to communicate with this guy, or how should it reach the vSmart. So it will also register with vSmart and do the control plane part of it as well. So it would have automatically learned about the routing of OMP through the vSmart. So in order to set this up on the V edge itself, all you had to do was plug it in. This is called zero touch provisioning, where you actually did not need to configure anything to set this up. There are a couple of requirements for a couple of requirements for zero touch to work. Number one, it has to be a physical device. It cannot be a physical V edge, physical WAN edge. That's one requirement. Number two, the second requirement that it has to have connectivity to ztp.viptela.com. So if you're on a private WAN, it's not going to work. Got it? So if these two things are in place, you actually can do zero touch provisioning. But what if I don't have internet connectivity? I'm doing it over a private WAN, or for that matter, I have a V edge. Okay, V edge as in what? A software V edge. If I have that, the configuration is very simple as well. You go on those devices and you do what is known as a skinny configuration. A skinny config is basically bare bone minimum configuration where you give it IP addresses so that it has reachability to VBOND. Basic configuration so that it can reach VBOND. That would include maybe the IP address of VBOND, which might not be ztp.viptela.com. It might be the IP address of your VBOND over here. All right, you do the skinny configuration and it makes a connection based on that. Once it makes a connection, you again redirect it towards the vManage where you have the templates for it. And as soon as you have the templates, it'll push the configuration down to your V edges. Once the V edges get the template, vSmart will take over and do the control plane or the routing. What routing protocol does the vSmart run with V edges to exchange the routes? It is that proprietary protocol that I talked about called OMP. OMP again is your overlay protocol. What is my underlay? Underlay is your internet or MPLS connectivity, not VXLAN. It is any connectivity. It is IP connectivity, basically. It could be cellular, it could be MPLS, it could be internet. It can be static routes, it can be routing protocols, as long as I have reachability, IP reachability between the V edges and the VBON, I'm okay. OMP requires reachability. The internal routes that you have will be routed through OMP. The underlay, which is the outside, can be any IP mechanism for making the connection. Let me finish this. I'll do that at the end in terms of if you want to know how the certificates work as well, specifically. OMP is, no, I think it's UDP 12346 is its specific protocol. All right, so you guys are okay with this? Understand how it works? Now, once the connection is done, so how did I make a connection over here? I made the connection based on what? I could either do it through ZTP or I could do it via the manual mechanism. Now, somebody asked me, why is it different for internet versus MPLS? The configuration is different for MPLS versus what do you call it? The private WAN. That is not true for everything. It is just true for zero-touch provisioning. For zero-touch provisioning, I do need to have access to ZTP to viptela.com. If I'm on MPLS and it's my private WAN MPLS, it will not have access to the internet. So that's where the problem comes in. That's where I told you you have to do it through the skinny configuration. But if your MPLS is providing you a leaked route from the internet and you can go to the internet through MPLS, and there's a DHCP server configured that will give it an IP address, you can even do zero-touch provisioning through the private WAN as long as you have access to viptela.com. It gets an IP address from the DHCP server as part of your DHCP IP address configuration that is assigned. It will also get the DNS server address, right? So normal. Now, the great thing about this is where we use DTLS and TLS, the initial connections that are made are secure tunnels, which are done generally based on DTLS, which is a UDP-based TLS, dynamic transport layer security tunnels. That's the protocol that is used to communicate between your V-edges and your controllers. The tunnel, the encryption that is used is DTLS. TLS, not a lot of people use. It's mostly DTLS. Although you could use TLS, but most of the time they're using DTLS. So the actual communication mechanism that is taking place between these devices, the security of it, the encryption part of it is done by DTLS. So these tunnels that are done over here are done through DTLS. Not only that, after it's established, these tunnels, to encrypt those tunnels is done through DTLS. So all these tunnels are DTLS tunnels for the security aspect of it. All right, so all this is encrypted. Now, correct, that is correct. If I get a chance, I'll explain that. So now what happens is I have set this up. One of the biggest advantages that we have over here is that we can use templates over here. Let me bring another topology over here that will explain it a little better. I have all right, let's take a look at this over here. Do you see my V edges? V edge 2, V edge 3, and V edge 4. The service VPNs are automatically encrypted using IPsec. I don't need to set it up. It's built in that it does IPsec tunneling between edges, my data traffic. PNP, as in the portal, is on the internet. It is a portal that you go and register your company and your devices. So it's not on the controller, it's on the edge, on the Cisco cloud. So let's take a look at this over here. If you take a look at my vEdge, I have an outside interface that connects up to MPLS, gig 00. I have a gig 01, which is connected towards the internet. And I have gig 02, which is connected towards the inside network. The same thing is on the London router, gig 0, gig 1, and gig 2, gig 0, gig 1, and gig 2. So Los Angeles, London, and Rome, their edge devices are configured almost the same. So what I can do over here is I can create a template for vEdge, in which I specify that my vEdge will have 3 interfaces, gig 00, gig 01, and gig 02. And when I create the template, I create variables. I can say the addresses will be provided when I add each one of those devices. So when I add a vEdge 2 for Los Angeles, it's going to ask me for the addresses for the gig 00. I'll need to specify it. I need to specify the IP address of Los Angeles. I'll need to specify the IP address of the gig 02 interface on Los Angeles. When I apply the same template to London, it's only going to ask me for those 3 variables. Whatever is variable will be asked. The rest of the things, let's say I'm running BGP as my protocol with my MPLS provider, I can run BGP with generic parameters over here, or OSPF as my PEC protocol. I can run that on gig 00, and it'll apply to all the 3 devices. This is all done in a single template. So as soon as this device comes and gets connected, I deploy the template on the device. It configures the entire template, including the internal networks that I need to route and the routing protocol that I'm running over here. Everything is done in one template. Within a matter of minutes, I can have multiple sites set up from this template-based configuration, where I create a template. In the template, I'll have some variable fields, which are like IP addresses on the devices, some generic fields, like maybe the time zone and stuff. And as soon as the device comes up, it gets registered, and the vManage pushes the configuration. When the configuration is pushed onto these devices, they will make a connection to vSmart for OMP. And once this is done, they exchange the routes from each other. So all this configuration is centrally managed. Configuration is centrally managed by vManage, but the actual OMP tunnels are set up between the vEdge and the vSmart. So all these routes that I have inside, if you take a look at my routes in LA, I have these specific routes over here. I have these specific routes in London. I have these specific routes in Rome. All these routes will be exchanged to vSmart, which in turn acts as like a route reflector and reflects Los Angeles routes to London, Los Angeles routes to Rome, and vice versa. So vEdge will know, vEdge 2 will know how to reach these London routes directly via VHC. He's just reflecting the routes. But by default, the way it works is the vEdges talk to each other directly. They don't talk via the vSmart. vSmart is just for the control plane. So I don't run any control plane between the vEdges. All the control plane is with the vSmart. Again, for redundancy, you don't want to have one vEdge, one vSmart. You might want to have multiple vSmarts over here. All right. So that takes care of my template part as well. To me, so far, I've given you 2 or 3 advantages over here. The ones that I really like. Number 1, centralized configuration. Number 2 is segregation of control plane, which is done strictly on what? The vSmart. Number 3, configuration. Number 4, actually, yeah, no, this is number 3. Number 3 is the templates. So if I want to, and that's one of the things that I'll show you in class, is the way you define or set up your templates and how easily you can get the sites up and running. It's amazing. I've been in the field for about close to 30 years now. It is one of the things that has really got me excited about this technology. It's really nice the way it works. So you can set up multiple sites up in a matter of minutes if you want. Within an hour, you can set up a bunch of different sites. You have a little bit of work up front where you define the templates, but once the templates are defined, it's so easy to set up. Now, the three things are done. The fourth one, which is basically this thing combined, which is the centralized policies. This is the most powerful thing within SD-WAN. And what is that? Let me ask you this, looking at this topology over here, how many different ways do I have to get connected from the edge to the edge? How many different ways can I connect up over here? Help me out. Either through the MPLS or the internet, right? Now, each one of them is known as a transport. So when I connect my devices, my sites to each other, I have different ways of connecting them up. And each way, each link that I have on my edge device connecting me to the other sites is known as a transport. Good so far, guys? You guys understand that? So how many transports do you see in LA, London, or Rome? Or for that matter, New Delhi? 2, correct? Now, by default, the way SD-WAN works, it doesn't make any distinction in between the 2 transports. So when it receives the routes, for example, Los Angeles receives all these routes from Rome. 172.16.41, 42.43, they're sent into the vSmart. vSmart sends it to Los Angeles. How many different ways can LA reach Rome? 2 different ways, right? By default, the vEdge does not give any preference to any other transports. So what is it going to do? Flow-based, equal cost, multipathing. So by default, Los Angeles will use both the MPLS and the internet clouds to connect up to Rome. By default. And I'll show you that. The other good thing about SD-WAN, the interface with vManage, is you can simulate flows, and even without sending any traffic, you can generate traffic. I can go to the vEdge. Actually, I go to the vManage and pull up vEdge 2, and from vEdge 2, I'll say I want to simulate traffic going to 172.16.41.x, going from this network over here. It will show you the path it will take from here to here. It'll show you that it's going to send some traffic here, some traffic here. So it simulates those flows without you having to generate any traffic. So you'll see that it's doing ECMP by default. So there's no preference given to either one. Okay, by default. This is the bare bones. You've configured it. It's up and running. It's going to do equal cost multipathing by default. Good so far? Now let me ask you this. You might want to give one a preference over the other. Let's say you're doing normal stuff right now. How do you give preference on a router? How do I tell Los Angeles I want to use this path to go to there? Weight, metric. Now all these things, priority, no, on a router, normal router, right? How do I do that? I do it by looking at, no, I'm talking about a normal router right now. I do it by assigning preferences to networks, AD, all those type of things, guys, are attributes that you assign to a network, right? You assign it to 172.16.41, 42, 43. Agreed? You don't assign using an ACL, Wesley. Look, think about it from a routing perspective. How do you tell a router, I want you to take this path to get to a specific destination? You do it for a particular network, don't you? Think about what I'm saying. When you go to RIP, EIGRP, OSPF, because that's what you're running over here, right? Critical, non-critical, Hemant, how do you do it? How do you classify critical, non-critical right now? You do it based on networks. This is a critical network. This is a non-critical network. Yeah, you use metrics, but you assign metrics, admin distances, all the different attributes that you talk about. Everyone is right. But I want you guys to think what you are assigning those metrics to. Are you assigning it to a particular type of traffic or a network? Routes, right? That's what my focus should be. You're not assigning it to applications, you're assigning it to a network. So now one of the things that you could do is you could say, hey, listen, I want all my voice traffic to be put into a particular network, and now I'll give this network preference. You get my point? Yeah, PBR is a way, but that's a manual way of doing it on each and every device. Good. What I have the ability to do over here with SD-WAN, and to me, that is the biggest advantage that you guys have, is a concept known as application-aware routing. When the traffic comes in over here, I have the ability to classify traffic based on deep packet inspection and ACL, a network, a whole bunch of different attributes where I can say if traffic is meant or the traffic that is coming in is, let's say, web traffic. I want this transport to be given a preference. So the preference that you're giving, the attributes, the metrics that you're talking about, right? You have been talking about giving metrics or attributes to routes. Now what am I doing it to? I'm doing it to what? The type of traffic. So I can say if traffic is going to 51 or 41, it is web traffic. Take this route, the internet route. What if it's voice traffic over here? I can tell it voice traffic for that network, go this route. You understand that? And there's multiple different ways. When you go through the course, I'll show you the different ways that you can classify traffic as web traffic or voice traffic. And based on that, I can direct the traffic using one transport over the other. Do you understand that? So it is something that gives you a lot more control to use these different transports. Not only that, you can dynamically build in what are known as SLAs into it. Okay? What do I mean by SLAs? You can specify if a particular link has to be used, it needs to give me a certain type of SLA before I will use it. So on a regular basis, these routers, they will have a tunnel established automatically, and you don't do anything of it. It's automatically done. They establish a tunnel using BFD. In the BFD tunnel, they keep on sending each other performance parameters. Oh, if I send a packet from VH2 to VH4 and I use the MPLS link, my response time, my latency is X. And the number of packets that I lose on this particular packet is Y. Those parameters are automatically put into what? My VH as part of my BFD tunnels. I have the ability to set up an SLA policy that leverages the parameters from BFD to say, hey, listen, I will want you to use this link only if it is giving me what? These SLA parameters. Generally not through the MPLS, generally because MPLS does give you quality of service mechanism, you generally do it on the internet site. Because MPLS does give you the capability of having your quality of service end-to-end, whereas the internet does not. Now you have the ability to use the internet in conjunction with SLA to pick a particular route that you have. Once you create the SLA, it's a policy that you define, and you can attach that policy to anything. You can attach it to a network. You can attach it to a particular application. So it's basically saying, I want this policy to be using this particular transport if this transport gives me that particular SLA. What if the SLA doesn't meet? You can specify your backup route over there. So I can say, listen, I want you to use web traffic over the internet if it provides your SLA, XSLA, whatever your XLA is. If it doesn't, then go to the MPLS, because MPLS, I do get end-to-end quality of service. Again, you have a choice to specify whether you want to do it strict. If it's not strict, then you can still use it if it's the only thing that's available. So again, there's options that you specify there. You can specify, if I don't get the SLA, I'd rather drop the call rather than making a choppy call. So it's entirely up to you at that point. And the beauty of it is all these configurations that I'm doing, do I need to do it on each and every device? Do I need to do a special policy on VH2 or VH3? I can do specific policies, but I am doing all those policies somewhere. One place centrally. I don't need to go to VH2 or VH3 or VH4 to do that. Everything is done from a central location. I'll explain that as well. Let me finish this off. We'll get to that. Good, guys. Everybody okay with this? You guys understand that? So do you see the advantage that you don't have right now? Now, coming back to your question about whether SD-WAN will get rid of MPLS or not, let me explain what it does in terms of MPLS. When you have MPLS, that's one thing that people don't realize what it does. MPLS gives you an end-to-end quality of service, which the internet does not. Because when you do an MPLS private WAN connection, we can go to the service provider and say, hey, listen, I want an MPLS application. I'm going to pay a gold service, but this particular type of traffic, I want to have X amount of SLA. And they can give you that capability on an MPLS. On the internet, because I'm going through multiple SLAs, I will only be able to do it on a per hop type of basis. I don't get the end-to-end quality of service on the internet connection. All right. So if I want that end-to-end SLA to be maintained, I still need MPLS. It is a transport that is reliable in the sense that it gives you end-to-end quality of service. Now, what this does is, let's say I want to do this. Again, I won't get an end-to-end quality of service, but I do have the ability to do this. So rather than getting one MPLS connection, let's get two internet connections, because MPLS connections are expensive. So I get one ISP over here and another ISP over here. You understand that? Now what I can do is I can set up my SLAs in such a way that at least I have the ability to measure what round trip am I getting to one versus the other. And based on that, play around with those SLA parameters to reroute or traffic engineer the traffic via one ISP versus the other. But at the end of the day, if you're really looking for end-to-end solution for having the SLAs that you want, the best way to do it is through MPLS. Because this is, again, I'm just checking it, but the internet, the ISP will not guarantee you an end-to-end quality service on it. By default, it does it automatically, Wesley. Remember what I told you. If you don't do any of the preferences, by default, it is load balancing over the internet and there. When you create the template over here, as I said, the templates have variables. So you'll say, my vEdge over here has 3 interfaces. Okay, so the template over here will say, the template that I'm creating for the vEdge has 3 interfaces, gig 0/0, gig 0/1, and gig 0/2. But the addresses that I need to specify over there, I'll set them as variables. The routing protocol, I want to run the same protocol on all of them, same parameters, they can be the same. So I said it once, it'll apply to every one of them. Any other parameters that are global, that like a banner, I don't need to change it on any one of those. I keep them the same. Once I have that, I have 5 devices. All I need to do on the 5 devices when I deploy it, it says, okay, you're deploying it to VH2. You need to put in these 3 variables. So you just put 3 variables and push the entire config based on the 3 variables. When you go to VH3, it'll ask you what variables do you want to put for VH3. So you put the 3 IP addresses for VH3 and it does the rest of the configuration for you. You understand that? So that's how you do the templates. You create what is known as, these specifics are called device-specific configurations. And you'll see that when we do the lab. So you do device-specific over there. After authenticating the V8 devices and pointing the address of the vManage, what is the remaining role of vBond? Keep alive with the V-Edge? No, actually it's done. It's done. For the next time the V-Edge goes down and comes back up, it'll first go to vBond to get authenticated. All right? Correct. That is correct. That's the initial part, user one. So that's, again, at the time of the authentication, it needs to go to the vBond anyways, right? To authenticate, and at that time, the vBond will tell the vSmart and vManage the public address of that device. Again, you don't do it like a percentage like that, George, but you can do it based on application. So you need to hard code it. You can say these applications go this way, these applications go that way. So you don't do like a percentage, 30% here, 70% there. Load sharing, not load balancing type of thing. How V-Edge connectivity ensure that SD-WAN in case of two internet links? Again, by default, it's going to do load balancing. Now, if you want one to be used better than the other one, then you would need to do those preferences that I talked about. There's no magic over here. If the internet goes down or your transport is down, I can't do anything. That's why what people do nowadays, they have three transports. They have in an ideal situation, you have your MPLS transport, you have the internet transport. As a backup, like a third option, you have a cellular transport. You have routers that come up with cellular. OMP is its own protocol. You're not going to run EIGRP over OMP. Why am I running? What's the purpose of OMP? It is to exchange routes. There's no there's no protocol running between the devices over here. What is the protocol used over here for? EIGRP, OSPF, ISIS is to provide IP reachability from where? From these guys to that guy. Once the reachability is there, OMP is the protocol. So your routes are getting exchanged based on OMP, not EIGRP, not BGP, not OSPF. Actually, at the time of authentication, it's required. If it goes down, it'll still work later on. But if a router goes down, it needs to authenticate, it won't be there. Okay, there's one good question was, you have two different templates. If I have two different SLAs for two different routes. That's a good question that you guys asked. Templates is generally for connectivity. Templates is for connectivity, making sure that the devices communicate to each other. The configuration that you see over here is done through templates. Now, the other thing that I'm talking about, the SLAs and all those type of things, that is not templates. That is done by what is known as policies or centralized policies. So once the templates are done, templates are basically IP address configuration of the interfaces, the protocol that you're running internally, the OMP parameters that you're running outside, those type of things. These policies, the SLAs, the app-aware routing that I've talked about, those are not implemented as templates. They're implemented as policies, like a forwarding policy, like a route map. You get my point? That's a good question, because that's very confusing in terms of what is the template doing, what is the policy doing. So template is basically used for doing what? The configuration of the interfaces, to setting up the actual network. But if you want to control the flows, you need centralized policies. You get my point? Can I have a network without having any centralized policies? Absolutely. No, you can. You can have a completely working network without having centralized policies. But what does that mean? That means it's going to use the default. What is the default? It's going to allow every site connecting to each other, the private networks, using what? ECMP full mesh. Got it? So if I'm not doing any centralized policies, it's working properly. Are the policies done on vSmart or vManage? Where do I do the policies? I configure the policies on vManage. The only configuration pane that you have is vManage. But once I do the vManage over here, it will push the policies, which are called centralized policies, to vSmart. This is the one that implements it. Automation is just to get it up and running, to initialize to so that the vEdge registers to the vManage initial. Once it's connected to the vManage, I can push the templates after that. ACLs can also be used variables not inside templates in the policies. vSmart is your control plane, correct. So ACL is just one aspect of your, not template though. ACL is a part of what? Forwarding traffic, right? So it would be part of your policies. Template would be IP address on the interface, IP address on a routing protocol on the interface, banner on the device, those type of things. That's what a template is. Good. So let's see how much we have covered over here. OMP is not between vEdge and vBond. OMP is specifically between vSmart and the vEdges. Definitely the physical, Victor. You don't need to be any type of scripting expert to be able to do that. This is all done over the graphical interface. Templates and policies are configured on vManage, but pushed down to your vSmart. So the configuration part of it is always done on vManage, and then it pushes it down to vSmart. No, that's the initial configuration. The authentication is done from vEdge to vBond, but then the control plane is between, the OMP is between vSmart and vEdge. vEdges talk to each other using IPsec automatically. Okay, do we have SLA for per cost queue? You can also do SLA per cost queue as well, if you want. Then any new configurations cannot be done, but it does not disrupt your networking part of it. You need to export that traffic. You would have to set that up based on a particular vEdge that you want to send the traffic outside your SD-WAN traffic. So you can leak out traffic or allow traffic coming in or going out of SD-WAN. There is no VXLAN over here. I'll do that. Let me finish the last couple of things over here on the slide. So if you take a look at this, we have done this. We have done this. Everything over here is done. We have two more things to do. One is TLOC extension. The other one is direct internet access. Let's take a look at each one. First of all, what is a TLOC? It basically is a replacement for all these different technologies that you have. Khan, that's an answer to your question. Let's take a look at TLOCs over here first. TLOC is an identifier for the transport. Let me explain that. When routes are sent out from vEdge to the vSmart and the vSmart sends it to the other vEdge, the next hop of that route. So for example, I have a route over here. I'll do a simple example first and then we'll do this one. Let's do this example over here. I have this route 172.16.41, 42.43. I send those routes using a local routing protocol over here to my vEdge. vEdge uses using OMP. Where does it send the route to? Where does a vEdge send the route to? It will send the route to vSmart. What protocol do I use over here to exchange it? OMP. He gets it. He will send that route over here. Good so far? Now, vEdge has two different ways it communicates to the other device. What is the other way? Right? It has two different transports. each way it can communicate or allow access to 41, 42, 43, it gives it two different next hops. So in this case, for roam, let's pick on one route, 172.16.41.0 /24 is reachable via, and I give it a router ID. The roam VH has a router ID assigned to it. In SD-WAN, the VH router ID is known as a system IP. It is not a routable address, it's just a router ID like you have in OSPF. So let's say the router ID is 10.1.1. Let's say 101. This is just for identification purposes, just like a router ID, which does not need to be routable in OSPF, EIGRP, BGP, just a identifier. Okay, so the next hop is what is known as a TLOC. The TLOC is made up of different things. So the router itself has a system IP, and what's the system IP? In our case, I said it is, I'll put it as, because I have 1, 2, 3, 4. Let's say it's 104. So its system IP, which is a router ID, is 104, but I can reach 172.16.41.0 either using 10.1.1.104 via the MPLS or via the internet. Just like a router ID has to be unique, the system IP has to be unique. It identifies the device. Now, because I can reach it from two different places, each transport is given what is known as an identifier, like a tag. This tag is known as a color. All right? The color basically identifies the transport. I can say my internet as biz internet. As my color. So I'm receiving this from where? From the, what do you call it? From the biz internet link. And the third thing, which is generally the case, is the encapsulation. You have two encapsulations that you can tunnel this traffic. One is GRE. Nobody uses it because it's clear text. And the other one is IPsec. So most of the time, the encapsulation will be IPsec. This combination of the system IP, the color, and the encapsulation combined is the next hop. And this next hop is known as the TLOC. So when you say the next hop is the TLOC, it is not just 10.1.1.104. It's 10.1.1.104 over the biz internet link and the IPsec. So the TLOC is made up of three components. What are the three components? The system IP, the transport, which is just a identifier for one transport over the other, and the encapsulation, which you can either use GRE. Nobody uses that because it's clear text. Most of the time you'll see IPsec. The default is IPsec. The same route is also received from 10.1.1.104, but it's received from the MPLS network. So I'll give that transport a color of MPLS, which is nothing more than what? An identifier for the other transport. That's exactly what it is. It's just a tag and IPsec. So what's the only differentiating factor between the two next hops? It is the color, right? So the color basically identifies the uniqueness of the two links that that particular VH has so that I can pick and choose between them. So now that I have the 172.16.41 route, it'll have two next hops. And the two next hops are not IP addresses. They are the system IP, the transport and the incap, which is known as a TLOC. So TLOC 1 and TLOC 2. And the TLOC is this particular combination. You'll see all those in your OMP routing table. So now when I go over here on VH2 and I check my OMP routing table, it will tell me that I can reach 172.16.41 10.0 through a system IP of what? 10.1.1.104, biz internet and IPsec, and I can reach it through 10.1.104, MPLS and IPsec. And what does it do in terms of which one does it give a preference to? It doesn't. It does what? What did I tell you does it by default? ECMP. Based on what? I have received the same route through two different T-locks. So you guys understand what a T-lock is then? How does a controller talk to each other? Controllers to each other are where? They're not outside. They're all where? The controllers are talking to each other locally. They're not going out. Where are the controllers at? This is between what? The V edges. Now, within there, when you see the system IP, there's another thing that OMP exchanges, which are called T-lock routes. In the T-lock route, it'll say for this particular T-lock, what is the public IP and the private IP? To reach this particular T-lock, what is the public and private IP for 10.1.1.104 biz IPsec? What is the public and private IP address for 10.1.1.104 MPLS IPsec? So it will know both the public and private IPs of those routes. And how does it find that out? When the initial registration took place between the, what do you call it? Between, how do I go to the bottom? Between the V edges and the VBON, at that time, the V edge lets the VBON know what is private and public IP are. So based on this T-lock, I would know the next hop for the particular T-lock, the IP address. So there's a special, there will be this public IP or whatever the reachable address for this T-lock would be what? Biz internet would be this IP. And for this one, it would be the MPLS public IP or MPLS outside IP. It's like NHRP, but it's done automatically based on the communication between VBON and VSPON. T-lock is to allow overlay tunnel. I didn't get that. T-lock is your next hop for the tunnel. You specified when you configure that interface, when you configure your G00 interface or G01 interface, you manually need to specify that G00 interface over there is MPLS or biz internet as the color. So you identify that at the time of the template, and that's done inside the interface template that you create. Good, you guys, everybody okay with the T-lock then? No, it is unique to that particular device. So what I mean by that is on the edge 4, you would need to have a different color for the two interfaces. It is not routable. The system IP is not routable. If you go back to OSPF, in OSPF, is the router ID routable? Similarly over here, T-lock IP, the system IP is not routable, but what did I tell you? In the T-lock, it will have the system IP. It's not just the system IP, it's also the color, MPLS, and IPsec. This is your T-lock. It will tell it what the address it needs to communicate. So for example, it'll say for MPLS, my IP address is, this is the routable address that you need. Similarly, the T-lock for 10.1.1.104, same system IP, biz internet, IPsec, what would be the public IP? It would be 192.1.102.x, this guy. T-lock is an attribute that is exchanged over OMP. It's not running over OMP. It's like saying OSPF cost is running over OSPF. It's an attribute. It's a next hop attribute. Yeah, you can say private 1 and private 2. SD-WAN specific with Cisco. It's actually specific to Viptela. No, with this one, it is specific to, what do you call it, with Cisco. So if you want this type of control, it's Cisco specific. Now, if you want to run any other SD-WAN environment, you would need to exit out of this SD-WAN environment. It's like going to the normal network. It is automatically done, George, automatically done. Everything that I talked about over here is automatically done. VPN user is basically your VRF. This VPN 512 is a specific VRF, which is called the management VRF. VPN 0 is the VRF for control, known as the transport VRF. Basically, all these different devices for control traffic communicate over VRF or VPN 0. And then your internal networks, which are these networks over here, are any VPN number, basically VRFs. So 1 through 511, 513 to 65,000. So those are your other VRFs that you can create. So VPN is nothing more than a VRF. That's a fancy name for saying VRF. Viptela is a V-Edge. Viptela is a company. Their edge devices were called V-Edges. Cisco acquired it. So all the edges from Viptela's time are called V-Edges. It's proprietary. As I said, you need to exit out of that. You basically set up one of the devices that's your exit point, like a border router that I showed you with SDA, Charles. That's what you would need to do over there. Can we use? No. It is, as I told you, there's specific hardware for that, right? That is correct, Khan. I told you that earlier on. This is your replacement for that. Okay, so now this part is done as well. Actually, T-lock is done. T-lock extension. Hybrid SD-WAN is where you're combining SD-WAN with the Cisco SD-WAN with other technologies like MPLS. So some part of the network is based on SD-WAN, the other part is not using SD-WAN. It doesn't have to be a real IP, it needs to be reachable. It needs to be reachable over the internet. You can do a one-on-one NAT with it, it'll still work. T-lock extension, another very important feature. Let me explain that to you guys. Let's say I have a company, I have multiple sites. I have an internet connection, I have an MPLS connection. You have one router, another router. Or one, I shouldn't see you even say it. I have an edge and another edge. Could be a V edge or a C edge. Now, I do this. How many transports do I have on this one side? How many transports do I have on edge 1 and edge 2? I have one on each, right? But for the site itself, I have an internet connection and an MPLS connection. Can this guy do load balancing? The answer is no. He just has one T-lock. He has one T-lock. So if you had to do any type of load balancing, would be that network-based load balancing I could do on an internet router, internal router. That app-aware routing, all those functionalities that I was explaining to you guys, SLA-based setups, I will not be able to do it because I will get the route. I only have one exit, and that is through the internet. He only has one exit, which is through this. The RRP will do what? They'll send the traffic to him, and he will then send it across. I don't have that app-aware routing anymore. You get my point. Remember, With app-aware routing, I could say if this particular SLA is met or this protocol comes in, send it through this TLOC. If it's not coming in with this, send it through another TLOC, right? So I do have two connections on the site. So I have two options over here. One, I don't get two edges, I get one edge. I do this. What's the drawback of this? On the site, I have a single edge and it can go down, right? For that edge. By getting two edges, I have redundancy over here, but now what do I need to do to support this? I need to get what? Two circuits. These are expensive. These are not cheap. Do you understand that? These are not cheap circuits. So I ended up getting 4 circuits if I want to have redundancy. So if I want to have my existing setup where I don't pay as much, I have this. I have the ability to set up a back-to-back link over here where what I do is I extend my connection, my internet connection, or sorry, this is the MPLS connection, by using a dedicated link over here. This link now acts as my transport link, which will be my TLOC. So this is my outside link now. The outside link uses the other link to go out. So if I get some traffic over here, I have the ability to utilize this link or this link to go out. So I can make that decision. So if I'm running VRRP, traffic comes in over here, or I'm running PBR, some traffic comes over here, some traffic goes over here. I can make the decision whether to send it through VH2 or here by looking at the TLOC. So I have 2 TLOCs over here. And the way I did that is I extended this TLOC, this MPLS TLOC to what? By using a back-to-back link to him. So now how many TLOCs does VH1 have? It has 2 now, one direct and one through the other one. This concept where one V-edge is acting as the next hop for the internal V-edge is known as a TLOC extension, because now I'm providing this guy with 2 TLOCs. And similarly, for the internet connection, this guy only has 1 TLOC. I'm going to use this link over here to use this guy as my second link. Do you understand that now? And this mechanism over here is known as a TLOC extension, which allows me the ability to get redundancy at the same time not buying multiple circuits. Data plane only happens at the beginning. Say that again. The question scrolled up. I didn't get a chance to do that. No, we don't need to do anything with the VRRP for TLOC extension. Yes, you do. Yes, you do. When the packet comes in, let's say you have internal devices hitting the V-edge. Now I have 2 TLOCs. So now I can do either load balancing over here, or I can do preference-based routing. Understood? Because now I get 2 TLOCs on each edge. And that's what one of the labs that we'll do over here is that. Data plane are between edges, so TLOC only happens at the beginning. TLOC is an attribute. It's a next hop. So every route that I send will have a next hop. You can use a single link Javed to establish that by doing sub-interfaces. You do have VRRP on the inside. That is the same thing that you can talk about any vendor for that matter. SDN, right now, most of the vendors that they do SDN, they are specific to their own company. The Cisco Meraki SDN is not nowhere close to the capability that you have on this. I talk with vSmart only in case of routing, which happens on a regular basis. Also policies. The policies that I talked about also done through vSmart. So the system IP of such site will be local for TLOC extension. System IP is the identifier for that device, right? So every device will have a router ID type of identifier. So now if you take a look at, this is a lab that we will do over here. So this is this lab over here. So there is no interoperability. You can exit out of my SD-WAN to get into another site. So over here, if you take a look at vEdge, it has one over here and one link over here, right? Now, each device gets a router ID. So far, so good. That's a system IP. Every device has one system IP, just like a router ID in a router. But it has multiple transports. So every transport needs to be identified so I can make that distinction between the two transports. And that's where the color comes in. So this connection, for example, this one over here is my internet. And this T-lock extension that I'm doing over here is going to be using the MPLS connection. But the system ID remains the same. But the system IP by itself means nothing, but it'll be combined with what? As I said, system IP is combined with the color and IPsec versus GRE. This itself becomes your identifier for your transport called the T-lock. I will show those are specific things that you need to take a look at when you take the class. Cisco Meraki also has a version of SD-WAN, but not as controlling as you have with Viptela. Are companies using DC traffic for SD-WAN? Absolutely. DC traffic, headquarter traffic, site-to-site traffic, every one of them. Nowhere close in terms of doing the control that I told you about over here is specifically like your, specifically for, what do you call it, SD-WAN with Viptela. Not just Meraki for that matter. If you do the same SD-WAN solutions from other vendors, except for 2 or 3 vendors, no one comes close to Viptela. As I said, user, take the class for those type of things. Those are specific things that you want to take a look at. I have multiple VRFs over there. So each VRF, you can see the routes from multiple VRFs. That is not true. That's wrong, Zishan. Very, very good solution. Viptela is a very good solution. Willow Cloud is good. Silver Peak is good, and SD-WAN is good. Meraki, Fortinet, those type of solutions are not good SD-WAN solutions. None. It's basically whatever you're doing inside the MPLS cloud, Amit, that's up to you. Whether you're using LDP or segment routing, it's entirely up to you. Also good. Not as bad, but not in the same league as the other ones. All right, so this part is done. So you guys are okay with this as well? This was the T-lock extension. Which one? This one is very, very, well, you need to go through it once, but once you learn it, it's fabulous. Let's not compare vendors. This is a great product. We can go on this. Everyone has their own preferences on that. You get my point. Personally, I love Cisco's implementation, Viptela's implementation a lot. Conceptually, it's the same. Now, which one is better? It depends on who you talk to. So the last thing that I need to talk about over here is configuring the direct internet access. That's something that's also very important. Let's say I have this type of setup over here. By default, when I set up SD-WAN on the edges, the WAN edges, any traffic that comes in will be backhauled to the data center. So whatever your data center is, let me take this as an example. This is my data center over here. This is my DC, my headquarters site. So let's say this guy wants to go to the internet over here. He has a direct connection to the internet, but because of SD-WAN, by default, what happens is all the traffic that comes into the router will be routed, whether it uses this TLOC or that TLOC, it's going to go through what? IPsec encapsulation, and it's going to send the traffic to the headquarter. Now, what you can do is on the headquarter, you can have route leaking or traffic leaking towards what? Towards other VPNs or other type of SD-WAN solutions or non-SD-WAN solutions. Internet. But that means I actually took the traffic, if you look at it, I had to go all the way across from where? From Rome to Dubai and come back out to use the internet over here. Especially if I have services like what? Office 365, I have maybe something on the WAN, some part of my data centers on the cloud, I would need to go all the way to Dubai to come out. So for those type of things, you have the ability over here to provide what is known as direct internet access or DIA. What that does, local breakout is another term for it. So what that does basically is you define that traffic that needs to go through the SD-WAN to get to the data center if it needs to. Any traffic that doesn't match your internal networks, you have the ability to NAT it locally or send it through Cloud Express to the internet directly for services like what? Maybe your DC on the cloud, which is basically things like AWS, maybe Azure, for data center stuff, or for your SaaS, software as a service like Office 365. You might not want to go and backhaul to the internet and come back across. You can go directly over here. And that's called DIA, direct internet access, or the local breakout. So that's also available. So it's better than going to the whatever your delay is, the local delay. You wouldn't get the delay of going to Dubai and coming back. You understand that? If I did not do the direct, the direct internet access, what's going to happen? It's going to go like this. Do you get my point? So rather than doing that, a lot of the companies decide to do direct internet access, which is a very common thing to implement with DIA. Why can't I have a default route? You do have a default route, but what by default, when you put a WAN edge over here, the V edge or the C edge, when traffic comes in over here, by default, it's going to put everything under what? The IPsec and send it across to the other side. You will have a default route where the default route will be on the outside interface. This is inside the inside VRF. So you need to go from this VRF, which is the inside VRF, into the outside VRF. And that's what DIA does. NAT is one of the ways to do it, Burhan. You do have the ability nowadays to have a small version of a firewall that is built in on the V edges, starting with 19.2, I think. They started building in a firewall inside it. No, DIA is direct internet access. Application-aware routing allows you the ability to specify which TLOC to use. With DIA, you're doing NATing towards the internet. By default, it's always on. By default, whenever you set up edge-to-edge communication, it is always using IPsec by default, unless you turn it on. Remember what I told you, you have the ability to specify your encapsulation. You have two options. You can either do it through GRE or IPsec. The default is IPsec. So if you don't tinker around with any of those settings, it'll default to IPsec. If you want security, definitely, yes. Now for the labs, what I have is you can do the labs on your own laptop. You do need to, this is done though. Do you guys understand this okay? So if you take a look at it, we've covered everything that I needed to do over here. It is like an IPsec tunnel. Initially, it will not be there. So as soon as some traffic comes in, it'll set it up. So you lose some couple of packets, just like you normally would with an IPsec tunnel. But once it's up, it stays up with a keep alive. So this is the vManage, vBond, vSmart. Do you guys understand this? Take a look at this diagram. You understand this diagram over here? Now you understand the management plane, the orchestration plane, which is your authentication, the vSmart, the functionality of that. I just put it like that. That's just an example for basically doing what? I would also put multiple vManagers for redundancy. Same thing with the vSmart controllers for redundancy. Now take a look at the transports. I've given you 3 transports over here, MPLS, internet, cellular, just to give you the capability to show you that you have multiple transports to go through. Now, don't look at this campus and say, oh, there's only one connection to the MPLS. It's just to give you an idea of the 3 different transports that you have over here. 3 common ones. Now the certificate server, let me explain that real quick. vSmarts and vEdges, what about it? Keep alive. It is done through BFD. As soon as these tunnels are set up, it automatically sets up BFD tunnels between them and sends a keep alive over there. Again, automatically done. You don't need to worry about doing it. Now the certificate server, somebody asked me a couple of times, one person asked me before as well. A very important thing over here is the role of the certificate server. You can use Cisco certificate server for a small charge, or you can set up your own certificate server over here. What a certificate server does, its job is to validate the different devices. So what happens is, on all these different devices, I will generate what is known as a identity certificate, what identifies that particular device. So for example, I'll say I am vh4.kbis.in, I'm located at this device, but if I send my information to VH3, how do I know he's saying the right thing? If I send my data towards VH3, how does VH3 know for a fact that this is coming from VH4 rather than somebody else bringing it in? That job of identifying or authenticating my devices is the job of the certificate authority. What happens, or for that matter, forget about the other device. When I go and register myself with whom? vBond, right? So the way it's done is, or for that matter, when vBond responds back to me, how do I know I'm talking to the right vBond? Maybe somebody is spoofing the address in the middle and it basically is saying I'm the vBond and he's really not the vBond. So in terms of this is where the certificate-based authentication comes in. The way it works is this. I generate my identification. So I'm a VH. I will generate my identifying parameters like I am vh1.abc.com. It has a public private key over here. It has my information, my location, my org ID, what organization I belong to. All that information is here. Once I have this information, I now need to, this is my information basically. At this point, it's nothing. I need to put it into a form of a certificate so that I can present that to somebody else. It's like saying, hey, this is my photograph and this is my information. But if I put that photograph and just laminate it and give it to somebody else, he will not take that as valid identification. So what the VH does or has to do, it needs to contact a certificate server that is trusted by your company. This certificate server can be a public certificate server, or you can set up your own enterprise level certificate server. So you take this information and send it to the certificate server. What the certificate server does, it takes the same information, but puts a signature on it, signs it, all right? And sends you that same information, but in the form of a certificate which contains your information now. Same information that was here was sent back to it, but now it's got a signature over here, and this is called an XF509 certificate. signed by the CA server. And the V bond, yes, it can. The CSR is this. Certificate service request is this. The certificate service request will go to the CA server. The CA server will take the certificate service request and generate a certificate for you. So WAN router, it is not this. CSR and certificates are two different things. CSR is your request, which the result of a CSR would be a certificate. Absolutely, that's what I'm saying. I can have my own CA server. Got it? So now the VBond will do the same thing. He will go to the certificate server over here, tell him that, hey, listen, I am VBond for abc.com, and this is my information, all that information, that is the certificate service request. The CA server will respond back and give him the certificate. So now, at the end of this process, every device will have what? Every device will have a X.509 certificate with their info, and more importantly, the signature of what? Of the CA server. Yes, it is. Good. Now, when the V-edge over here, let me finish this and I'll explain that. When this V-edge sends the certificate over here to VBond, how does the VBond know that this guy is saying the truth? By looking at the signature. But how does it know it's the right signature? What I need to do on VBond and V-edges is to download what is known as the root certificate. Root certificate is the certificate for the CA server. You get my point? So when this guy comes in, how do I verify that this guy is saying the right thing? By verifying the signature by looking at the root certificate for the CA server. So at any given time, your device will have two certificates. What are the two certificates every device will have? The root certificate for the CA server, which is used to verify the other guys, and it'll have its own what? ID cert, its own identifier. It will send its cert to the other guy. The other guy will use the root certificate to verify. You get my point? And then vice versa, I'm going to send my ID cert over here. It's going to do the certification over here. Now, the option that you have, you can use Cisco's CA server. If you do that, again, for a charge, that certificate is pre-installed. The root certificate and the ID cert is pre-installed on your physical devices. You don't need to worry about it. But then you're paying Cisco to maintain the CA server. It's a service that they're selling you. Whereas if you want to do it on your own company, you can set yourself up as a CA server, which is an enterprise CA server. You can use OpenSSL. You can use the Microsoft CA server and do it based on that. So now when this device is coming in, I'm using the certificates to authenticate. Can I have a dual link between DC to MPLS provider? Yeah, just physically connect it up, just like over here. So I would have it like this, and it's better because now I have two TLOCs. As I said, you can have the CA server in the enterprise, or you can do it based on Cisco. Yes, you can. You can do service chaining as well over here, which is basically sending your traffic to either a maybe a load balancer, maybe to a firewall before you let the traffic come in. You can also do that, and each one would be a different transport charge. So if you have two links to MPLS for redundancy, you would give each one a different, what do you call it, color. apps, what do you need to worry about in CCI Enterprise, Victor? All this SD-WAN and SD access, the CS server, absolutely. I don't think they're going to do a Cisco Cloud CS server. You would need to set it up. Now, in terms of labbing, as I said earlier on, one of the things that you need to do is you need to have the licenses. Remember, somebody said it's hard to set up your WAN edges without the licenses. All the licenses are controlled by Cisco. I can show you, I have my topology. The topology that I showed you is for EVNG. I can help you with that. All right. You can set up your own lab. It does require a beefy server. Just the vManage is about, if you really want to run it, is about 20 to 24 gigs of memory. I would say a 60 gig device is what you need. Okay, I will give you the topology, but you do need to get your own licenses. If you want to use my lab, I've set this lab up on the cloud. I've set it up on G Cloud. If you have your own licenses, I can give you my topology, and you can do that over there. I've set up this on G Cloud, the entire topology, including, because it's my own, I have my licenses on it as well. It's got everything else. Yeah, it's EVNG Pro. And then all I charge you is like $2 an hour just to use the labs. And you should be able to do most of the labs in about 20, 25 hours. There's about 36 labs that I have. So maybe about $70 for accessing it. If you don't want to use the cloud, you can set it up on your own device as long as you have licenses. So as Wesley said, he has his own licenses. He can do the lab on his own device. You do need a big beefy device for that. So that's why this helps if you want to use that. I will provide you the UNL file. That depends on your partner discounts that you get. So you need to ask your partner for that. You need to go to the PNP portal on cisco.com where you download the software and stuff. In PNP portal, you need to create a smart account. And over there, you register your organization and you get the licenses over there. 16 CPUs, Wilson, on my G Cloud. You can do with 12. The one that the configuration that they had for 60 gigs was with 16 CPUs. Yes, you can. Remember the edges that I had, the border devices, the private WAN edge, that could be your vEdge device over there. This course starts on Sunday. At the same time, 8 p.m. this Sunday, Dubai time. So you need to do your conversions. Google is very good at it. Now, let me show you the content for the two courses. 8 p.m. I wrote it. 8 p.m. Dubai time. All right. So let me show you the content first, and then we'll discuss that. Let me show you the content, and then you ask the questions after that. So the content that I have for the two courses, this is the content that I showed you for the SDA. Now for SDA, because it is completely based on what? It is completely based on physical devices. You need to use a rack, and I give you 20 hours on my SDA lab. If you need more, you need to pay for it. I haven't decided the price, but I'm not going to make money off of it. It's going to be really cheap, maybe a couple bucks or $3 an hour for the DNA Center lab. The topology that I have, my physical topology looks like this. Where is it? Let me see if I have it over here. Actually, this one over here. This is my topology. I have one cat, which is basically my border and my control device. I have the WLC. We're not going to use it for this particular class. I have the underlay as a normal 3700, and I have two edge devices. Besides that, you have your DNA and ICE. So this is the topology that you're going to have to do the labs. All of the labs which are listed over here are some things that will be part of the course. So I'll explain these things to you guys. I'll actually demonstrate these labs to you guys, all the way from setting it up from scratch. So you have no knowledge about SDA, you'll be able to configure in a complete network, including LAN automation for SDA. Once that's done, once this part is done, this is the second part of the course, but this is about 31 labs along with the workbook. All right, so you need to use my particular device for that. You will have 31 labs for this. And then, or actually before this, we will do the SD-WAN part of it. SD-WAN again has about 36 labs, 37. There are more labs that I'm going to add, but let me at least show you those. So for SD-WAN, we will set it up again from scratch, initializing the vManage, the vBond, the vSmart, how to initialize the C-Edge as well as the V-Edge, both of them, configuring the bunch of different templates that you need to configure, and then the policies, a whole bunch of different policies, including things like TLOC extension, NATing. We'll also do DAI, load balancing, hub and spoke, a whole bunch of different things. SD-WAN, it is called EVE-NG Pro that you can use for that. Yeah, that's what I've done as well. I have it on my laptop as well as on vCloud for setting up the SD-WAN. So besides this, I will also be covering the Python programming part of it. So that will give you everything that you need to upgrade. If you have a route switch certification already, to upgrade your certification to EI, all the different things will be provided. All right. These are the things that you get. You get over 70% of the certification. I will give you the training for the Python that is required for the networking part of it. But there's a bunch of different programming things, programs for programming on the internet, especially for network. We'll do Python over here. Technical support to do what? To help you with your job? No. Yeah, for sure. I teach it on a regular basis. Come to class, you'll see that. How do you register for the course? I'm going to be sending you an email for the registration. I'm doing that tomorrow. I'm starting FTD tomorrow. How much memory do I have personally on my laptop? 128 gigs. Okay, the price. The price for one of them, if you just take one, is $550. For both of them, including Python programming, is $1,000. You can make credit card payments. You can do PayPal, online transfer, a bunch of different. You will get an email regarding that. If you want, you can also send me an email at, let me put the easy one. KB at all right. The 1,000 is SDA, SD-WAN, the lab workbook, the classes, and Python, which is free. If you're in the current EI class, it's free for you. It is part of the annual package. The annual package basically gives you access to all my CCIEs that I do on the weekend, including this class would have been free. I do ICE training as part of my CCIE security track. I'll teach Python from basics towards the end of this class. Total, how many days? About 8 days, 8 to 9 days. If you want to do the annual packet, it is $3,000. Which includes all my CCIEs. EI, security, data center, SP, as well as CCD. Just send me an email. I'll send you the information. There's something wrong with my website. I called the data center. They were down, so I'll try to see if I can get to them tomorrow. For which one, Ahmed? Wireless I do once in a while as a boot camp. It's not part of the annual package. Personally, I would say right now, if I want to get into this field, I'm looking for a job, SDA, SD-WAN, you forget about the certification, you'll get a job just based on these two technologies. It is hot right now. No, not for these classes, no. No, send me an email. You have the email address over there? Send me an email. %70 of what? Each yes. So this is about 40%. It is the future. Farhan, everything is going away from the legacy-based system to this. DC core, not at this point. It will include all the access, all the CCIE boot camps that I have for the entire year, including these other courses that I do that are technology specific. Like, for example, if you sit in that SDA or SD-WAN class, that would have been included. So if somebody's over here, that is part of my annual package. It's free for them. They don't need to pay for this. Yes, you will. What I'm doing right now, I'm setting it up on my website. So you will get access to, you'll get an account, you log in, and you can view all the videos will be there. This video, I'm going to email you, but the videos for the classes, the SDA, SD-WAN classes, they'll be available to you on my website. You need to have an account to log in and take a look at the video, the recordings. Absolutely. I have started a security session already. Tomorrow, I've gone to the point, I've finished the ASA firewall. So if you want to jump in, you can jump in tomorrow. I'm starting on this Sunday for 8 weeks. Yes, I will send an email to whoever signed up for the class. I will send you an email to download the link. Thank you, Majid. Trust me, do this part. This is, I mean, I've not been excited about technologies. It's going to change the way stuff is done in the future. The thing about that is you still need to have knowledge about OSPF, ISIS, all those type of things. But what's going to happen is rather than having 10 people do it, you will have one person be able to do the entire thing. And you be that one person that does that, not the other 9 that will get kicked out. And it's happening. Trust me, it is happening. Thank you so much. I agree, Farhan. Send me an email, Nafiz. There's only 8 weeks, so there's not much you can do with it. Most of the classes are only on the weekends. I do boot camps during the week, like I did one for SD-WAN about a month ago. And that is free if you're part of the annual package. And the other thing that's good over here is you attend one class, that particular class that you attend, you have unlimited retakes for that. You can re-attend the same class as many times as you want. The full class is about 3 months. Hopefully in the future, right now, I'm so busy with the stuff that I'm doing, but maybe in June or July, I'll do an ACI webinar as well. Majid, I will send you an email after the class is done. If you have registered through the link, if you don't get an email by tomorrow evening, send me an email. You have my email address over there. $3,000 is the annual package. I know, Godwin, I will do that. A little busy with some things right now. I will eventually do it. All remote. These SD-WAN is through the cloud. The other one is through a VPN. The SDA is through VPN. This is a weekend class, Sunday only. Thank you. So as I said, I would highly recommend taking this class. Believe me, I'm not saying it for the money part. It is something that you can really benefit from in the future. SDA-SDWAN, 8 p.m. Dubai time on Sunday. It'll get you started, Umair. Probably in July, Shiraz. Throughout the year, I'm going to be doing classes, Mohammed. Throughout the year. It's on a regular basis. I will, Godwin, probably July. All right, guys, you take care. Thanks for coming. Hopefully it was informative. See you guys in class. I'll see you, a lot of you guys on Sunday, right? It is more difficult, but it's also more fruitful. To me, it's my favorite track right now. It is better to buy the annual package. It's a fabulous track. Yes, you will just pay the difference. What was that? Yeah. You just pay the difference. See you guys then. Take care. Sunday is the full class starting. If you take the SDA-SD-WAN class right now and you want to upgrade to the annual package, you just pay the difference at that point. Sunday it is. Yep, I know, Shiji. Take care, guys. Good night.